This year, FreeBSD is using Open ZFS. A couple of years ago, we switched from having our own fork of ZFS in tree to collaborating together with other operating systems on the Open ZFS project. So we get one code base that we can run and test on different platforms, operating systems, and so on. Yeah, so that's where we are. So what can ZFS do? So we have a couple of interesting things there. For example, it takes care of data integrity. So it checksums all the blocks, which means that if you have a corruption on your disk or your memory is faulty, then ZFS has mechanisms of detecting that and potentially correcting them, but it will tell you that something is off and you have a chance to act on it, which is pretty great. It also has data consistency. So what it means is that when you are updating a file, you never end up with a partially updated file. It's either an old version or a new version. So if you have a power a power breakage, let's say, like in the middle of updating a file, then ZFS, well, it will not save partial results. You will always have a consistent state no matter what. And then it also gives us pooled storage. So you no longer have to partition your disks beforehand. You just throw all your disks into one pool. You can then design your layout. You can mirror some of those disks. You can use some cool things like RAID Z. And once you have all of that, you have a pool of storage where you can create data sets, and they can grow and shrink. And if you want to move files from one data set to another, you can freely do it. It's gonna the storage is gonna flow where your data is. So that's pretty neat. So ZFS is pretty awesome. It also has things like snapshots. It also has efficient remote replication. So if you have, you don't really have to like send all the bytes over the network if you want to have the same contents on a different machine. Like if you are iteratively keeping two machines in sync with ZFS, you just send like diffs of data sets, which is very, very handy. It also has compression. So you don't have to zip your files to save on the storage. ZFS can do it in the background for you. And you can choose from different compression algorithms. It's pretty interesting because apart from saving storage for you, so you can save more data, it can also speed up your workloads because you, if the data on the disk is well smaller because of the compression, then you effectively do less I/O to get it from the disk. So if your disks are slow and you compress your data well, then everything speeds up. It also has cool things like deduplication. So if you have various files with the same blocks in them, then you can save just one copy of a block. It's sometimes used. It has some caveats, but it's there. And then of course RAID Z, so different layouts for your pools where you can have different levels of redundancy of disk and so on. Quotas, all the cool stuff. Boot environment, so that if you upgrade your system and it doesn't boot anymore, you can easily boot back into the boot environment before the upgrade, and you can resolve your issue from there. You don't have to pull out a pen drive from an ISO or like a CD or whatever and like rescue your machine. You can just kind of boot back to where it was still working and then figure out what went wrong. So it's a very powerful file system, which is also why it's sometimes difficult to integrate new things into it because you have so many other things to take into consideration that are already working in it. Yeah, so it makes sometimes implementing things a bit more challenging. And then we also need to take a look at different layers we have in ZFS. So we are only going to look at this very simplified view of what ZFS looks like inside. So this is on the kernel level. At this point, we already got an I/O request, and we are arriving at the ZPL. So it's what it roughly does. It translates the VFS request calls into ZFS-specific internal machinery. Then we hit the DMU, and at this point, we can choose if we want to go the direct I/O path, skipping the cache, the arc, or we want to go the buffered path through the arc. And once we decide, we end up in the very same place, which is the I/O pipeline that orchestrates all the read and write operations, and then there are some other layers beneath that. But essentially, direct I/O only operates on this one layer of this whole big stack of what ZFS does inside. And the arc is actually one of the most, I guess, famous parts of ZFS because it's so powerful. It's caching things, and it's very important for ZFS because this is where all the performance, or like a lot of the performance lies. So it's useful for caching. It balances between most recently used and most frequently used. So the nice thing about this cache is that it adapts to your workloads. So depending on your workload and how often, how you use files, it's going to adjust to that and support you in the best possible way. It also keeps track of various useful metrics, so that you can then tune it to be even better at what it does. For example, it has ghost lists. These are super cool. So what they do is that sometimes you have a machine where you have, for example, tool-to memory. So, and when you have a very heavy workload, it will happen that sometimes when you have a file cached in the, when you have a file in the cache, and then you have many more files coming in, you will have to evict this file from the cache. And then if it turns out you actually want to use this file again, but it's not in the cache anymore because it was just evicted, the arc takes note of it and increases the metric called like ghost hits or something, which means that if the file was there, if I didn't evict it, you would have a hit, but it wasn't there, so I had to go to the disk. So I don't know, consider like retuning me or add more RAM or do something about it, potentially. So that's nice. It also uses as much RAM as it can, which is also great, and it's very aggressive about it. But at the same time, it backs off when it needs to. So when you think about it, it's the trade-off in the arc is that you get better latency and throughput, but you pay with CPU and RAM. And this is exactly what people want to avoid when they use direct I/O. So direct I/O is essentially a flag that you add to random to various function calls, like read and write. It was first introduced in XFS for database workloads for the purpose of bypassing some of the caches to prevent unnecessary I/O. So for example, they wanted to avoid read ahead, so prefetching data. Unfortunately, it's not standardized, so there is no single document explaining what you can expect from the direct I/O. Everyone is doing it in a slightly different way. There is a consensus how to do it, but it's like you can't really refer to a document and say that this is how it's supposed to be done. So Open ZFS developers reviewed various available documents, like the Linux Open manual page, and followed various conventions, look at like how other file systems implement that, and came up with like a set of features and assumptions and whatnot to make it a reasonable implementation for direct I/O. When it comes to who benefits from direct I/O, or like what benefits from direct I/O, so there are a couple of things. Some examples are applications with their own caching, like databases. So having like multiple caching layers that are not aware of each other may lead to problems. So disabling caching when you have a database with its own cache may lead to performance gains. You also have workloads that I would call write and forget, like application checkpointing. So imagine you have a computation that's running for like a month or so. And you really don't want to lose all the results if there is a power outage. So you save the partial results every now and then. And when you're doing this, you're not really planning to read it anytime soon unless there is a breakage. So you just want the data to reach the disk as soon as possible and then free up all the resources back for the computation that you're running. So in this case, having a cache all the data you just wrote makes no sense. Same for read and forget. So when you're restoring from a backup, you just want to restore everything as fast as possible. You don't want to, cache all the different files in the cache and like with a possibility to read them in a moment. You're not gonna do that. So direct I/O could also help in this case. And direct I/O is also getting quite popular recently because of NVMEs. So it's not that direct I/O is only useful for very fast pools, but certainly with faster hardware, the overhead of Arc is no longer negligible. So you can see actual benefits of skipping the Arc and just going direct I/O. There are higher chances if you have NVMEs in your deployment that direct I/O is going to do nice things for you. No guarantees, but higher chances. Right, so chapter 2, pitfalls. So in this chapter, I will lead you through a benchmarking setup I prepared for the purpose of this presentation. And first, we'll start with explaining the setup, so what we're dealing with. So the hardware I used was just a laptop T480 with not too powerful processor anymore, 16 gigabytes of RAM. The disk I used for the benchmark was a CFast card connected with a USB. So it's like a small card. It's it was good enough for the tests. For the software, I was running FreeBSD15. ZFS is 2.3 something. The important part is that direct I/O is already implemented in this version. The record size of the pool was 1 megabyte. And I used FIO for the workload generator and Hyperfine for orchestrating the benchmarks. And on the right side of the screen, you see the FIO job file. So when you want to benchmark your things with FIO, you can write a job file, and it looks roughly like this. So you have a global section on line 3. This is where we have like common variables for all the other workloads I defined later on. So group reporting is something about the output, doesn't really matter. NSync makes the workload call an fsync at the very end to make sure that all the data actually reach the disk. It's also a sequential write workload, so we are trying to write as fast as possible, not trying to like randomize our writes, but like get everything from the disk that we can. 4 jobs, block size is 128K. So this is the size of our requests. And in this case, we have a file size of 128K also, and we have like 1,000 files. And then we have 3 different workloads. We have the raw that goes all like directly to the disk, no ZFS involved. Then we have the direct workload, where we are writing to a pool with the direct flag enabled in FIO, so FIO will try to do direct I/O calls. And we have the buffered, which is like the standard way of going through the Arc, right? So FIO is just behaving like a standard application. Right, so we run the numbers. We run the buffered at the top. We run direct at the bottom. and it looks roughly the same, right? So in a way, you can think that, OK, so no performance gains for me today from direct I/O. And this is a wrong assumption. So if you start investigating and you look at the I/O stats sysctl, you'll see that there were no direct calls performed at all. And I was, OK, that's curious, because we enabled that. So why it's not there? It turns out that you have to enable direct I/O before you do anything. So OK, so there is a sysctl for that. DIO enabled. I think it will be on by default in FreeBSD soonish. But for the time being, you have to enable it. OK, so cool. So we do it. So now ZFS is allowing direct I/O. We run the numbers again. And still, no direct I/O, no bytes, no count, like nothing. Like ZFS is not registering any, not letting through any direct I/O. OK, so we have the job file. We make sure that like the property for our data set is actually allowing direct I/O. Standard says it is. Does any one of you see a problem here? What could be wrong? So let's fix that. Iteration number 2. It turns out that direct I/O is ignored if a file is smaller than the record size. So we had very small files, 128K. Our record size of the pool was 1 meg. So in order to avoid read, write, modify cycles, and which decrease the performance significantly, the consensus in the development community was that we should not, like if someone requests direct I/O for small files, let's let them through the ARC. It's going to be a better call, and that's how it works. So OK, let's try something else then. So now we do 1 file per FIO job. We do big files to make sure that we have like files that are big enough. So 4 gigabytes. I also set I/O size to make the benchmarks shorter. And then the offset increment helps me with the raw disk. So when I have a pool, I have 4 files. But if I write directly to the disk, I have just 1 file. And without the offset increment, all the jobs would write at the very beginning of the disk. So that's not ideal. With the offset increment, I make the 4 jobs write in 4 different places of the disk. So it just makes the benchmark more reasonable. So we run the numbers again. We look at the numbers, and it's still the same. And then it's OK, fine. We've been here before. So we check the I/O stats sysctl, and it's 0 again. Like, OK, that's not great. So we iterate further, because it turns out that ODirect is ignored if the issued writes are not record size aligned. So when you're writing and your requests are not aligned with the record size, you're also ignored. So it's like, OK. So you see, like, there are various places where even if you enable direct I/O and you specify that you want to use it, if your application is not fulfilling those requirements, you won't see any direct I/O traffic. So all right, so let's make sure that our requests are big enough. So we go for 16 megs, and we run the benchmarks. This time I included the results for the raw workload, and it all looks roughly the same, which means that we are most likely reaching the limits of the device, because like the raw workload, which is testing the maximal capacity of the disk, is basically the same as our buffered and direct I/O performance. So there is nothing really we can gain from setting direct I/O. cool. So this can also happen. And just to be sure, we take a look at I/O stats, and now we can actually see that there are direct I/O requests going through. Cool. So let's try one more thing. This is all quite exciting, right? We got direct I/O to actually do something. So let's see if we can modify our job file so that we can see what people want to see from when they decide to test out direct I/O, right? Because usually you have a disk that is capable of performing very fast, but your experience shows that your application is not achieving that. So you're like, okay, with direct I/O, I'm gonna skip all the clutter and just like go for the maximal performance. So let's try to see if we can have something like this. So I set the block size to 1 meg, and now when you when you see presentations of people who benchmark direct I/O for their use cases, then this is roughly what you usually see. So you see the raw performance performing very well. You have the buffered one that performs worse, and you have direct that performs somewhere in between. So that's usually what you want to see, as in you wish you see it when you apply direct I/O. But it depends on the workload, of course, right? Not every workload can be sped up with direct I/O. But finally, we see a difference. That's pretty nice. So in summary, there are a couple of things to take into consideration when you're benchmarking direct I/O. So first, remember to activate it. This is very important. Avoid small files. So when you have your application and you want to use direct I/O, make sure that the files you're writing are, like you have to check your record size, the size of the files you're writing, and then check if your I/O is fulfills the alignment requirements. These are all things that you may maybe not thinking about, but if you want to check out direct I/O, first review those things in your application. Also, disk's raw performance, like you cannot really go above that with direct I/O. If you're using the buffered path, maybe if you're serving everything from the memory, then you'll have wonderful numbers, right? So you can have a lot better performance with the buffered path. With direct I/O, you are capped at the disk's raw performance. And yeah, usually with faster hardware, you are more likely to see benefits of direct I/O, but that's like also possible to see it on hard drives. So let's take a look at the implementation details. How does direct I/O fit ZFS? How is it trying to be a good citizen that is not breaking everything that ZFS promises? So there are like various little things that are all kinds of little implementation details. So for example, direct I/O does not imply authsync. So when you are issuing direct I/O, the only thing it does, it skips the arc. But it's not making the bytes land on disks straight away, right? You can still choose if it's a synchronous call or an asynchronous one. Maybe the name direct I/O is a bit misleading because it feels like when I'm using this flag, my bytes just go directly to the metal, straight there, and it's just skipping all the like unnecessary things. But that's just not the case. Also, indirect blocks, so all the metadata, they are still buffered. Direct I/O is only about the user buffers. So if you have a workload where you are dealing with a lot of metadata, then it's also possible that you won't see any performance gains or like, it's also something to take into consideration. Like, direct I/O does not turn everything into, like, it does not turn off the arc, right? The arc is still there and is doing a lot of important things. Interestingly, apart from the standard setting that is on by default, we also have the always setting, which means that ZFS will do its best to kind of treat all the I/O from your application as direct. So if you have an old application and you just you don't want to rewrite it, or you just want to test if direct I/O would benefit it, then you can set direct to always and see what happens. It's pretty handy. Right, so also the alignment requirements are different depending on the I/O. So for write I/O, they're a bit more strict. For reading, not so much. The important part is that whatever happens, ZFS will make sure to keep our data coherent. So by using direct I/O, you're not sacrificing any of the safety. Your data is still safe. Other important things are like that mmap files, they're always buffered. And also, if you end up using direct I/O and then also modifying the same buffer within the same transaction group, it won't wreak havoc in ZFS. ZFS will detect that and redirect your calls to the arc. So everything is going to be all right there. You don't have to be careful when you're using direct I/O. ZFS will make sure to protect your data. And there are also some unimplemented cases. So for example, direct I/O doesn't work currently on ZVols, and it's not possible to mix the application with direct I/O writes. So it's, again, another small thing that you have to keep in mind when you are testing it with your deployment. So in summary, direct I/O is relatively easy to use from the user perspective, right? You just enable a couple of sysctls, or just like one, and it's going to be on by default soon, so no sysctls for us. You can start using it very quickly, but then you should probably think twice and maybe measure 3 times before you deploy it, because it has various caveats. And it's a very powerful tool. It helps with performance for a certain group of workloads, but it's certainly not a bullet, like a silver bullet for all the performance problems. And I feel like it's often advertised as such. So when I was doing my bachelor's and I first heard about the direct I/O, I thought that like it's weird that we even have non-direct I/O, because like why would you want to do like extra things if you just can send your data to the disk? That feels so I don't know, simple and straightforward. And I think that's the meme that's circulating around. The right alignment is critical also, and you should probably try tuning other things of other parts of ZFS first, like the arc, or adding L to arc to speed up your deployments. Direct I/O is an option for optimizing your setups, but it's probably not the first thing to think about. And as I said before, ZFS with direct I/O will not eat your data. It's implemented in such a way that whenever there are some edge cases where we are overwriting a buffer that's in flight, or we have a file in the arc, but we also are trying to use direct I/O to overwrite it on disk, then ZFS will do the right thing and manage all of that for us, and it will, like, the data will be fine. Perhaps it will be a bit slower because our call will be redirected into the arc or something, but at the end of the day, it will all be fine. Thank you. That would be the end of my presentation. Yes?
You cases that would benefit from direct I/O versus not? Like when there has to be certain page sizes, is it database application like Postgres, or what kinds of things would make you try and use it?
So yeah, so the question, I think the question was if I know any workloads that benefit from direct I/O. Is that correct? So yes, as I mentioned, there's this group of different workloads. The databases are often good candidates for direct I/O, and situations where you really don't care about the cache. So you are just writing the data once or reading them once. In those scenarios, caching them for potential use in like near future doesn't make any sense because you know you don't need this in the cache. So in those cases, these are the simplest ones. For more complex workloads where you are reading and writing, and sometimes you may want to reread the file, it may still be beneficial, but you have to check it on a case-by-case basis. Thank you, but it's a good question. Yes?
Do you know the difference at a more technical level between direct I/O, so calling read-write with ODirect, versus setting a property of your data set of primary cache and secondary cache both to none? Because that essentially disables caching altogether, right? Is there a difference there?
So the question is if disabling the arc or setting it to cache none of the things differs from direct I/O. It probably does. I don't have the answer at the moment. Maybe Alexander has.
On that side, I was actually had some comments in that direction too. Direct I/O is a new thing. It's still in development, and just recently, maybe a month or two ago or less, I pushed one more interesting patch, which actually integrates direct I/O, not direct I/O, but ODirect flag with my earlier work done about a year ago, which I called uncached I/O. With uncached I/O, ZFS is instructed to reduce caching, not do all the paths through the arc, but reduce caching as much as possible, which means once data are written to disk, as soon as transaction commits, it's data evicted from arc. Same as on read. We can do speculative prefetch. We prefetch them. We can read them. The application can read them. As the moment application reads the data, they're evicted from arc. So we can do uncached I/O going through the arc. And part of that work earlier, when you set primary cache to metadata, all of your reads and writes still going through the cache, but they're getting evicted from cache immediately as soon as data, as soon as they're no longer needed. Setting primary cache to none is too extreme because metadata too often reuse it. When you read multiple blocks, you need indirect blocks again and again and again, and not caching them would be a waste. But primary cache metadata is interesting thing by itself, since it allows ZFS to save some memory copy in normal arc operation. It's forgiving a few things, and it is actually faster doing that when you don't need actual caching. But it's actually went very well after integration with ODirect. As I was told, direct I/O has a lot of limitations when it goes about alignment, about many things, and sometimes it's getting annoying because, as was told, direct equal to standard means it will fail if you do something wrong. But many applications, since ODirect is not exactly properly specified, not documented, different applications may have different expectations. And for example, for BSDs, right now impossible even to get those expectations from file system. On Linux, they recently okay. On on Linux, they actually recently introduced variation to fstat, I think, fstat something, syscall, when you can get what is the alignment restriction for specific file to implement direct.io. So now on Linux you can properly know what to do right. FreeBSD at this point doesn't have this equivalent syscall, so you have to just hope and guess, and if you guess wrong, it will fail, which is not exactly a usable approach. That's why I think that I mentioned Pache implemented couple months ago, that actually wire or direct, which is not good enough for direct.io, through the uncached I/O. For example, you have your buffer not aligned, or you're doing small file I/O, or you're doing something else which cannot do direct.io properly, and in that case, you'll get uncached I/O, which is still better, it's still faster than going through the cache. It will still not pollute the cache, not wipe the cache when you do like read once or write once workloads. You get all the same cache benefits, but without penalties of direct.io, because direct.io does have penalties in some workloads. For example, if you simply do not have enough requests to make your disks busy. If you have pool of dozen disks, but you're sending one request at a time, and obviously you, or direct has to wait for request completion until it actually returns to application. It's uncached by definition. It's direct. So you have dozen disks. Please send 100 requests, 1,000 requests, whatever, if your application can. If it can't, or direct is likely not for you. But in that situation, uncached I/O can help, since you can still have read ahead, write back, everything works. And other things would be interesting to see on FreeBSD actually. Linux also got it very recently, I think it's last few months. It's been developed like 6 months ago, but getting landed only now. You can mark specific, I forgot, operation or a file with also, they actually also call it uncached I/O. I don't pretend on the name, but I was first. When you can mark something as a file or I/O as uncached I/O, and you write a file, and it will go through the cache, but it will evict immediately. And we could also actually implement that uncached I/O without forcing direct I/O, so that application can choose whatever they want. Direct I/O, great. Uncached I/O, also fine. So there are some integration work still could be done, and it looks like should be pretty nice picture altogether.
I won't be repeating this. But thank you. That was a great explanation.
I had a maybe simple question. You said that we have a maybe simpler question. You said that we should not use direct.io. There's really no benefit if you have a lot of metadata in your I/O operations that you're doing. Can you characterize a little bit more specifically what you mean by metadata?
So since you have indirect blocks always cached in case of direct I/O, then if you have a lot of those indirect blocks, then what I meant is that the bottleneck may be somewhere else. So it might be one of the telltales that if you're not seeing improvements from direct I/O, and you have a lot of those indirect blocks.
So my question is a little simpler. Like,
Yeah.
what situation would cause let's say a file on my file system to have those indirect block presence? Is it when he has extended attributes? Is it when he has ACLs on it? Is it when he has, like, what is the metadata, practically speaking, that causes that?
I think that one of the things could be if you have a lot of files in a directory, then the tree is then when you're storing this tree of all of the directory, then that's a lot of indirect blocks. So this could be just off the top of my head, and potentially a scenario like this. But in practice, I'm not sure if this is enough indirect blocks to really be causing this sort of a situation. So I'm not sure, but I would bet on the directories with lots of files.
Okay.
Yes?
Should we write something in tuning.7?
Uh, yeah, definitely. But then the tricky part is that what would you write there? That there is direct. So there are like that's the thing. ZFS can be tuned in many different ways. I think we have an article on the wiki explaining some of the tuning tricks that you can do to ZFS. But ultimately, the defaults that ZFS ships with are very solid, and they are usually good enough for most use cases. And to tune ZFS, you really have to know what you're doing, because like most of the time, when you just modify a random variable, hoping for it to help you, it will make things worse. So yes, documenting things is very important. At the same time, it could be a lot of false promises if written incorrectly. Yes, we have 50 seconds.
Sorry, to reply to both of you.
Yes.
You said there is an article on the wiki, but wiki, I think either no one reads it, or it's usually unmaintained, so it would be good to at least have it in the man page. The same article, just copy and paste it in the wiki, and say, do it on your own.
Yeah.
Be careful.
I think moving things out of the wiki is an ongoing project, and from what I've heard, there are plans to do something about our wiki. Maybe one of the solutions would be to like move the content out of it. Yeah.
Right.
Yeah.
Yeah, there's two issues with the wiki. One is it's an obsolete software.
It is. It is very old.
The
Yeah.
other issue is there's a lot of data in the wiki that should be in the handbook. I know the first problem is being worked on. People say others are working on the second one, but I don't have any names who belongs to this group of others. That might be an opportunity for people to improve the handbook or the appropriate set of docs as well.
Definitely. Definitely.
That's it.
Yeah, thank you. It could also be that this documentation should actually land in Open ZFS documentation. Then it won't get stale that easily, I think. Yeah. Cool. I think we ran out of time. Thank you so much for your attention, and enjoy the conference.
Hello everyone, welcome to my talk. My name is Roller Angel. I'm a senior systems administrator. I'm based out of Florida in the United States. This is about automating my lab. I use Ansible to set up everything and then Salt to keep it going and maintain it over the long term. You know, in my job, you really learn the importance of managing the configuration of your systems and understanding how careful you need to be when you're making changes. It's good to have a good workflow when you put changes into production. You know, we do change management system where you talk about what's going to go into it, what could go wrong, how you're going to roll it back if it doesn't work, and how do you prove that the change is successful. So with these tools, it makes it a lot easier to get something tested, working, and then out the door into production and in a way that's reproducible and you can validate it. And then also, I deal with a lot of auditors, and these tools prove to be valuable in that realm because they can do what's called file integrity monitoring. So if you manage the state of everything with these tools, then you can prove that you know the state of these files, and if they were ever to change, that you would have a difference, and you could show that you could log that somewhere, you could send it to a monitored inbox. There's a lot of different methods to take the data from these programs and put it into other areas to solve problems, and you don't have to invent other solutions, because I know sometimes you'll get to the 11th hour and then find out that file integrity monitoring needs to be in place, or else you don't get a pass. And you're like, oh wait, what do we got to do? And then you just realize, no, we've already had it. We can prove, and then you just show that to the auditors and they're fine. So stuff like that makes it nice. So today what we're going to cover, we got a little bit to go over. I like to pack a lot into my presentations. I really want to send you guys home with something that you could take away and go run your own lab. So we're going to cover why you would want to automate. I'm going to go over the lab and even the laptop setup. So this laptop is set up through Salt, and I'll show you how to do that. The lab can actually run the automation tools, and the laptop can just connect into the lab and pull its state directly from there. So I'll show you how to bootstrap a new system, both a new system like a new laptop or even a new lab jail, because this is all about jails and FreeBSD. Because, I mean, if you're going to run FreeBSD, you want to get away from VMs, I would say, from my experience, just because you need more horsepower and more hardware if you want to run VMs, because the first choice you make with a VM, how much hardware am I going to emulate for this thing? And when you make that decision, you're taking that away from the host and giving it to one specific VM, and then you're immediately limiting your possibilities. How many more of these can I make before I've got to go buy more stuff? But with jails, you can make that decision way later. You can just keep running jails until you start to see a problem with resources, and then maybe you can decide you need to upgrade something, or you can look into resource controls and try and see if you want to go down that rabbit hole, or maybe just tweak your storage setup, put some new jails on a different hard drive or something like that. Play with ZFS, those kinds. So this is actually ZFS jails. I love ZFS. It's super nice, the built-in native encryption and just the endless possibilities for solving problems. It's a good thing to have. I'm not such a big fan of UFS. I know it is nice, and there are people that really like it, but when it bites you, it bites pretty hard, and it's sad. I mean, it's hurt me a few times where FSCK, and you're like waiting and waiting, and the system needs to come back online, and you're like, what the heck? So I don't ever run into those problems with CFS. Then we'll talk about automating system installation and package setup. When we add a laptop, we're just doing SSH access. So literally going through the installer in FreeBSD, and at the end, rebooting and not touching it again. You go into the jail host, you SSH into your laptop with Ansible, and it starts setting it up. So you don't have to install any tools or anything on it. You just go through the installer, put yourself in the wheel group, create a user, and make sure you leave the default setting with already has SSH running. But then we're going to talk about, so Ansible I use to set things up that don't exist already, right? Because Ansible's really good about, hey, I see Ansible more like I'm the coach now, and Ansible is the player. I used to be the player. I used to have to go through all the plays myself. I used to have to run them all. And now I can kind of be the coach, back up a little bit, and just throw the playbook down and say, run the playbook. Like I know what to expect. You guys need to do exactly what I told you to do, so execute. And then you get the same results every time because there's no human error in the equation. It's, that's what I really like about machines is they don't lie, and they don't, if they make a mistake, there's usually a reason. You could figure out why. But Salt, I like to manage my machine states with Salt because maybe I don't want SSH running on my machine, or I don't want to manage the keys or rotate the keys, leave the keys somewhere, try and come up with a place to run Ansible. So with Salt, you have an agent that you install on the client, and you have a master that you install on the Salt master. And if you run the Salt master inside your LAN, then anything that can talk to it can be controlled by the Salt minion, can all be controlled by the Salt master. And it just makes it really nice because in the background, the keys rotate automatically. A new minion can come and talk to the master and say, hey, I'm here. Where's my state? And the master can have it in its unaccepted keys list. So it's not allowed to see anything yet until the master says, yes, I accept your key. And then it can start to pull its state down. You can go both ways. The client can ask for a check-in on the state, which is nice. You can put that into your logs. You can just run you can do a test equals true. So you can not change your state, but you can ask what should my state be, and it'll output any changes that it detects and what it's going to do. And you can always just save that, email that, put it in a log somewhere, and that way each of your machines has got a record of however often you want to run that, what state it was in at the time, and if it matched what it was supposed to match. But you could do the other way around. You could do from the master and contact all the minions at the same time and tell them, check in. Like, I want you to update your state to whatever changes that may have happened. Okay, so the lab hosts. Like I said, this is FreeBSD 14.2 with ZFS on it. So after I installed it, I just went and needed a couple extra packages. I needed sudo. I'm just using git lite and Ansible. So with those three installed, the only thing I needed to do is go into vi sudo and give the wheel group privileges. Now it's ready to clone. So what is this repository? I've actually built a set of playbooks for you, and that you could use to build your own lab and try this out. So there it is, BSD Programming Workshop, ZFS Jailhost Lab. So that's all I've done today is set up a computer, run these couple of commands, and then I'm going to run the playbook, and it's going to build my lab. So why automate? I don't know about you guys, but so many times I've been up late trying to solve a problem, trying to get Plex Media Server to talk to other services and automate all of them. So if something comes down, it can talk to another thing, send an API call, and make a bunch of magic happen. Well, there's nothing like getting it all working and then it's running for a little while, and then hard drive will die. Or what happened to me was I was running it on an old motherboard, an old AMD processor, like the FX ones from back in the day, because it was just fine. It was just running for a really long time. But at some point, it burned up because it was always on, and it was always working way harder than it probably should have, and it just stopped working one day. And then I was like, oh, geez. And so going to bring that machine back, I figured, oh, this is probably a good time just to rebuild it. Well, those types of scenarios, you realize there was a lot of tricks. You were pretty clever, and you don't remember what you did. You're like, what was the trick to get the sticky bit to go so the folders, when another project, what was it, like this program and this program and this program need to share a directory, but I want them all in the same group. And I can't, oh crap, what was that? And then you start digging through your notes, and you can't find the note, and you always find it like a few weeks later when it's too late. there's the note, I remembered it. But with these programs, instead of sitting there at the computer and solving everything, I like to go to a different computer and pop open a lab computer, drop a lab computer in, and start building a Git repository with the playbook in it. And anytime that I want to run a command to change my lab server, I'll put it into Git, I'll check it into place, I'll go to the lab server, and I'll pull the repository down, and I'll run the playbook. Because then I force myself to never run a command manually. I always have to come up with the command, run it through Git, and sometimes it gets really annoying because it takes a couple extra steps, and it feels, there's the temptation to just go to the command line. It's right there. I'll just type the command. Here, I just need to edit the one file. But it'll just keep coming back to bite you because, oh yeah, I switched the interface to the other interface because, oh, the NAT wasn't working right. It was the bridge network, or whatever it is. There's always some little thing that you do that later you're going to not remember what the heck it was. And so why automate? Because it's going to save you from all that, and it'll get you back to your list, right? Like, I don't know about you guys, but I have all of Michael Lux's books. And I haven't read them all yet, but I've read a lot of them. And I want to read them all. And I want to go, every time I'm reading one, I'm always putting like, I'm going to do this at some point, and I'm going to do that at some point. And you don't want to just keep, stalling on the same projects when you could be way further ahead if you would have just automated the things that you had already learned and stop trying to relearn them. Because time flies, and before you know it, you're kicking yourself because you're like, oh, dude, I wish I would have spent more time on this, and I wish I wouldn't have went down so many rabbit holes, and I would have just solved the problem. So what you'll see that's cool with automation tools is you don't have to know all the tips and tricks. You don't have to make everything idempotent. It doesn't have to be super pretty. You could start with shell commands. Literally, you just say module command, and you just want to run this command, then run this command, then run this command. And then at some point, you'll be like, oh, they have a copy module? I should probably just use that. And you can start updating it later, but don't get too hung up on making it perfect. Try and get your project done, and if it bugs you enough times, go and optimize it. But I find myself, every time I get an idea to optimize something and I go fix it right away, I never end up doing the thing that I sat down to do in the first place. So those are some tips about automation I would share with you. So here's the FreeBSD Jails lab. What I did was I just recorded running this playbook that I was just talking about. So I'm going to show you that recording here in a second, but that's my lab. So I got a desk at home. It's got the CPU cooler sitting underneath it. It's always running, and that's a Dell Precision. The cool thing about the Dell Precision is they made them for architects, and they didn't sell a lot of them, and so they offloaded a ton of stock to certified refurbished resellers on eBay. And those guys there's different ratings on eBay, and the 100% refurbished guaranteed one is legitimately a brand new computer. It has the tape on it and everything. It's all brand new. And they just can't sell it as new. So you can get these things for a killer deal. And the cool part about them is they have Xeon processors, and they have 4 NVMe slots. And they're using DDR4, which is a little more affordable. So you can just bump it up to 128 gigs of RAM if you want. Mine came with mine came with I believe 116, and then I bought some 32s to go in it. So I'm up to 96 right now. I just didn't feel like taking out a 16 and putting it on the shelf. I figured let's go with 96 and see where it gets me, and it's been perfectly fine. And then I bought a couple extra SSDs to mirror for the labs. So the one that it came with is for the host operating system, and then the other two are mirrored together, and that's where all the lab data sets are. So this is a different view of it, just to show you. It's kind of hard to see, but that's the built-in Ethernet cord coming out. I renamed that one to Home 0. I renamed the interface to Home 0. I'll show you a little bit in a sec. And then this is a USB-C Ethernet adapter that's got Ethernet coming out of it, and I call that one Lab 0. That goes directly to my ISP's modem. So I don't have any. I even bought my own modem, and I don't use any of my own ISP's equipment. I just bought my own modem. I registered it with my ISP, and I plug it into this. And so, and then this access point is radio only. So this black cord coming out, Home 0, goes into the back of here, into the WAN port, and then now I've got any of my devices that connect here, get an IP address from the lab, and this red cord coming out is just on an Ethernet switch that's also built into that access point. So I can plug that Ethernet into whatever I want and get it on the network, plug it into another switch if I want to. I seen some advice one time about, I think it was like a YouTube video where they were like, never plug two switches into each other. Don't go from one switch to another switch. And then the idea was because it's not highly available and one of the switches might break, and then your whole thing will go down. And it's like, and then I'll just replace it. It's not a big deal. It's my home network. I'm not that worried about it. So yeah, you can plug in a switch to another one if you want to. It's fine. I wrote about this in the FreeBSD journal. That's the virtual lab for the BSD programming workshop. That was just command by command. Before I automated it, this is what I came up with it for. I was asked to write an article. I wrote an article about that. This is what I was interested at the time, so it's what I came up with. And it's been one of the best things that I started on because it just kept evolving and kept evolving. And now it's so nice to have. Like I really, really like it. So what I'm going to show you is I took the, I'm using VirtualBox to create a couple VMs so that we can kind of emulate what I just showed you, emulate that Precision laptop as VM1. So that's the FreeBSD gel host. I've put 3 adapters on there, just a NAT network, and then another NAT. So the NAT is EM0. The NAT network is EM1. And then the other NAT is EM2, but I didn't rename that one. So this is my rc.conf on the jail, just showing you that I've renamed EM0 to Lab 0, and I've renamed EM1 to Home 0. OK, so these are the interfaces on the jail host. So you'll see up there, there's Lab 0, and here's Home 0, and here's EM2. So it's nice when you rename the interfaces and you do ifconfig, and they just show up with the nice names that you gave them, and you don't have to remember what EM0 was or what EM1 was. EM2, I'm only using for, on this VM, I'm using EM2 just to get internet on the machine while I set up the lab. And then I don't need it anymore. And I'll show you why I don't need it anymore in a minute. And then over here is 2 bridges. You have the Lab 0 bridge, and you have the Home 0 bridge. So in the Lab 0 bridge, there's 2 members. One member is Lab 0, and the other member is E0A gateway. In Home 0 bridge, one member is Home 0, and the other one's E2A gateway. So you might be asking what happened to E1A gateway, because I went from E0A and to E2A. I'll show you in a second. But those are called e-pair devices. So what's cool about FreeBSD jails where they're at today is you don't have to do that weird trick where you're creating another loopback address and sharing an IP stack from the host to the jail and getting confused. You can just use VNet and create separate stacks for each jail. So when you do that, you use e-pair. There's a really nice script in the user share examples called JIB, Jail Interface Bridge. And you just give it an interface, it'll create a bridge for you, and then it'll make one end of the e-pair connected to the bridge, and the other end is connected to the jail. So just imagine it as a physical Ethernet cable. And the bridge, imagine it as a physical switch. And you're just plugging in ports to the switch. And you're running, and the cool part about them is you can take a real cable and plug it into a virtual switch, and then you can take a virtual cable and plug it into the same switch. So then it gives you all kinds of ideas of like how to combine the physical world with the virtual world in a way where you don't have to reimagine it. Like my work's done a lot of changes where we're running everything in AWS, and it's all managed services. And when you go into these environments, it's like, yeah, we do the same thing, but it's different, and we do it different, and everything's different. And you start to, it really gets to the point where you start to lose some creativity because it's not the same. It's not like a real switch with a real cord plugged into it. And this is so cool because it is. It's just exactly the same as a real computer. So if you didn't have to set up 20 computers, you could just jail 20 computers and run those cables into your switches and just be like, just in your mind, it's like you're running your own lab, but you just can't see it. Hopefully we'll get there one day where you could put on these goggles and you could see your lab. I think it would be so much better for training courses. And then you could see the data going between things. And then when the firewall is blocking something, you could just see it stopping. And you'd be like, oh, that's what's happening. But until then, we just have to imagine it all in our minds. OK. So what was that other interface that I skipped? It's a VLAN. So I made a VLAN called LabNet because I needed a device to give to JIB. So JIB would create my LabNet bridge. My LabNet bridge is what I use for E0A update. That's my update server. E0A salt. That's my salt server. E1A gateway. So that's where the one went for the gateway. And then now all of those are plugged into the same switch. So that makes it they're all in the same LAN, which is nice. OK. So this is going to be what you see if you go into my gateway jail and you look at its network setup. So there it is, E0B gateway, E1B gateway, and E2B gateway. And you'll see that E0B is just getting an address from the modem or whatever's upstream, or the NAT. In this case, in VirtualBox, the NAT's just a 10.0.0.2.15. But the E1B gateway, it's setting its own address, and it's saying, hey, I'm going to be 10.66.6.1, because I want to be the gateway for this LAN. And E2B is saying, hey, I'm going to be 192.168.66.1 for the home network. And so there it is. There's your lab network. Here's your home network. And there's upstream at the top. OK, now if you didn't catch this earlier, this is a callback to the home bridge. Did you notice there's an Ethernet MAC address on the bridge? Now, this I didn't realize when I wrote the article for the FreeBSD journal. But this is the best thing about building these tools and replacing your devices at home with FreeBSD and actually using it, is you start to try and figure out how would I do this? And how would I do that? And when I seen that, I'm reading the handbook, and the handbook is like, you can just assign an address to the bridge. I was like, wait, what? Hold on a second. So if I run DH client on my home 0 bridge from the lab, the jail host, now it's a member of the bridge and it's getting its IP address. 192.168.66.11 now. And I was like, oh, that's so cool. So now I don't have to use the EM2 anymore. I can get my address from the home bridge, and now my jail host can now be on the same LAN as my home network. And I didn't have to plug in another device. I didn't have to use Wi-Fi. I didn't have to do anything. I just used what was already there and assigned an address to the bridge. And that just blew my mind, because I was like, how cool is that? Like, why wouldn't you let it have an address? Because it's not an actual switch, right? Like, it's emulating a switch, but it's also virtual, and you can just assign an address to it. So I was like, gotta love that stuff, man. So cool. This is very important if you're gonna use VirtualBox. When you create a NAT network, and your idea is to use it as, like we're gonna use it here, as an actual, I've got a gateway, and it's gonna control all the traffic for all the other VMs that might wanna talk on that lab network, that home network. You have to set this promiscuous mode to allow all, or the traffic just won't flow. And you'll think something's wrong with PF, or you're like, why is this stuff not working? It's just that. So make sure that's allowed all. And this is VM number 2, the laptop. It's got one device. It's on the NAT network called home network. And if you look at what home network is, you could put anything. 10, 28, 6, 0, it doesn't matter. Just make sure the DHCP server is disabled. There's no check here. Call it whatever you want and assign it to the VMs that you want to be on that network. And that's it. Because this doesn't actually get used by anything, you can control it all in FreeBSD. Oh, and then on VM2, since we want to do display, the idea is to pretend like VM2 is my laptop. And I want to start X and have a GUI and all that with Xorg. So if you change the graphics controller to VBox VGA from whatever it's set to, VirtualBox is going to tell you did something wrong. Probably just because they want you to use their latest driver, and they're assuming you're using some operating system that they support a little more. But if you don't use that driver, you're not having display in VirtualBox with FreeBSD. So just ignore that. Ignore the warning, but set it to VBox VGA. OK, this is the FreeBSD Jails lab. So all you're going to see is that I'm doing DH client to EM2 to get an address, because I haven't done anything yet except what I showed you earlier, just installed a couple packages. So now I'm git cloning that git repository. And then I'm going to cd into that repository that I just cloned and run ansible-playbook and run the playbook. And it's going to take my fresh installed machine that only had Ansible, sudo, and git, and it's going to set it up as a jail host. And it'll go through every single thing it needs to do. I need the jail service. I need the base.txt from freebsd.org. I need to create some data sets. We're going to load the PF kernel. We're going to rename those interfaces that I was telling you about. This is actually going in and setting up all those names that I set up, the home 0 and the lab 0 and all of that. Once it's done, you're going to have a FreeBSD jail host, and you're going to have two jails. So it's setting up the gateway jail, and it's setting up a salt jail. And then in the salt jail, it's copying these salt states. So I've included in the repository a set of salt states that I'm copying into the salt jail so that we can have something to use to control the state of our machines. So that's it. Now we've got a lab jail, or a lab host with jails. Come on, buddy. OK, this is the laptop. So like I said, sudo dh client home 0 bridge, because I want the jail host to be on the bridge with the laptop and the rest of the home network. So I'm just doing a ping real quick to verify I've got internet. OK, everything's good. And then I'm going to go into the jail host lab, but I'm going into the add desktop to salt playbook. And then same thing, Ansible playbook. And I run the playbook, but in this case, I need to do lowercase k and capital K. Those are saying I need to provide an SSH password, and I also need to provide a super user password. So when you run those, it'll tell you, hey, you also need SSH pass. So now I'm just going to package and install SSH pass. If you try and log in with Ansible to a server that doesn't have a key, it's going to ask you to use SSH pass. So I'm just going to go run that playbook again now that I've got SSH pass. And I just wanted to show you that you might get that. So there's no tricks here. This is everything that happened. And then there you go. So it's using the raw module to install Python 3.11. Then it's installing sudo. It's configuring the sudoers. It's installing salt. And then it's setting up the salt minion to talk to the salt master. So what I want to do now is log into the salt server, which is from the jail host, you can just jump into the salt. So I'm in salt asking it, what keys have you seen? And there's a new key for the desktop, and I just added it. And I told the desktop to come up into its state. So now I'm logging into the desktop, typing start X, and the desktop is configured. So it's that easy. You accept the key, you apply the state, and the machine now is how you wanted it to be, and you didn't have to touch it. You just start X and use it like you would like to use your desktop, which is beautiful. And there you go, just showing you that the desktop actually works. You can auto-size it, and so that means that the graphics drivers are working fine in VirtualBox, and the services that must be enabled. And then just showing you that the internet's working. You can go to websites, et cetera. This is my website, bsd.pw. I try to put notes and links and videos on here. OK. And then I'll just shut down the machine. Yes?
I don't know either Salt or Ansible that well, but I do intend to learn it. Which one needs a server? I think does Salt?
It's Salt.
Salt, right?
Yep.
Is the server part of the lab itself, or is it a distinct thing? Like, where is the server running?
There's a server called, I'll show you real quick. So here's, I'm connected to a VPN right now, right? Open VPN to my house, to that laptop I showed you. Because I have a jail in my house called VPN, and that's what's providing this. And now I can actually log into Salt. So Salt is .2 for me, and there we go. So Salt is actually just a regular jail, right? It's got E0B Salt. It's just a jail. It's at .2, and then it has a bunch of states and use your local etc salt states. And there's all my states. So I've got the base, I've got Bob and DB1 and Gateway and Media Center and OpenVPN and Poudriere and Salt and an update server and a workstation and a bunch of stuff.
So as part of the stand-up for it, you create the Salt server?
Yes, I created the Salt server for you. And that's basically just etcrc.conf. That's basically just these couple lines, right? You've got Salt Master Enable. And the cool thing about Salt is it can also be a minion of itself. So you can Salt Minion Enable as well. Because you would also want to manage the state of the server, the Salt server, somehow. So just do it. You don't have to do anything special to do that.
Thank you.
Yep. OK, and then, OK, this is the additional jail. So I've also included an Ansible playbook to add a jail, because you're going to want to add a jail to make more jails for your lab. So all you need to tell it is the name and the number that you want the jail to have. So this one's literally just, and this is how you pass in variables. You're just saying -e, lab client host name is update, and IP address is 3. And then you run the playbook. It sets up another jail called update, and it gives it the IP address that ends in .3. And it'll do all the same stuff. Start the service, restart the jail. And now when you go into salt, you check the keys. There's a new key that needs to be added. You just salt key -A to add the key. And now you can apply the state. So you can go to salt, you can apply the state. You don't just have to do star, you can do like a wildcard, like update star. I just want the state to apply to that new update server I just added. And it'll go, and now the update server is set up. This update server is a very simple one. It's just Apache, and it caches files for 1 day. And the only path it lets you go to is 14.2-release on FreeBSD. So one of the salt states, the base salt state for all the salt servers, for all the minions and all the FreeBSD machines, is just to change freebsd.conf and change the host to this update server. The reason I do that is because when you're running a lab and you want to update all your servers, being a good net citizen would be to only ask the FreeBSD update server for one set of update files. And then once it gets into your network, you share all those update files with all your servers, and they're not all talking to FreeBSD. You're saving them bandwidth, and it's a nice thing to do. OK, next one. OK, so maintaining and scaling with salt. As you saw, I ran that salt state.highstate command. That's how you, from the salt master, how you would tell the machines that you want them all to check up and apply any state. So a cool thing you can do is you can say FreeBSD_update.fetch, and they'll all go fetch their updates. And like I said, since their update server caches files, they'll only get one set of files from the FreeBSD upstream, and they'll share them amongst each other. And then FreeBSD update installs all the patches. Here's how you do package updates. You just package.update, package.upgrade. And all your machines are up to date, even your laptop. So that makes it really nice. Instead of, I used to find myself on one machine updating it, and then jumping to another machine and updating it, and then at some point forgetting that I didn't update the media server machine or whatever, and it's falling behind. So this is nice. You keep everything going. You maintain them all. And that's why I really like Salt, because with Ansible, right, you got to find a place to run it first. And then you've got to think about wherever it's running, it needs to be able to talk to all the other things. So there's got to be some sort of network connectivity there. Also, there's got to be an inventory, and it's not dynamic. There's no way to add stuff to the inventory. There's a lot of tricks for inventory. That's a whole rabbit hole. But what I'm saying is, the machines you're trying to control don't talk to Ansible and say, hey, I just joined the network. Can I be part of the inventory? They don't do that. So you have to go in your inventory manually and make it all nice, and you can add it. I mean, it's sure, like if that's how you want to do it, but where are you going to maintain that? And what if you lose that computer that had the Ansible on it? Because you're not managing the state of the Ansible, are you? With Ansible? Are you in the inventory for that? I don't know how you're doing that. But with Salt, that's not a problem. You can manage the Salt server with Salt itself, and the inventory just kind of is a growing, living thing. And then the keys, like, are you putting SSH keys on all these machines, and you're SSHing to them all, and then at some point you need to rotate them? You talk to an auditor and tell them that you leave keys on machines, and to make it easier, you don't put a password on them, or you store the password in memory, or you do some weird stuff. They're gonna bite you really hard. And maybe you can talk yourself out of it, or you can come up with some cool tricks, or you can use the YubiKey and say, hey, the key's over here, and it never leaves here. So someone actually physically has to go to the machine, and we touch the thing. So there's ways around it, which is but I didn't even have to consider any of that stuff really with Salt. I mean, it's in my local network, and nothing can talk to it unless it's got my SSH key for that server, and I'm coming in through my VPN. So I've got my VPN protections, and then I've got my SSH key protections. Then I just have to rotate that one SSH key that I use to get on my network, and that's not bad. I could manage that. And then the other cool thing is you can command.run. So I can just say, hey, I want to know the FreeBSD version of everybody. Like, everybody, what's your FreeBSD version? They'll all come back to you and tell you. If you don't want them all if you get too many machines and you don't want them all talking at the same time, you can do batches. So you could do B1, B2, however many you want to do in a batch, and it'll chunk them into batches. So that's super nice. So here's a little clip of those commands running, so you can kind of see what they look like when they run. You've got the state.highstate one, calling everybody and saying update, and they all just kind of fly across the screen, and you get a little summary for each machine about like if anything changed. Here's the FreeBSD update fetch, and that's just, you're seeing every single machine got its updates, and then you do the FreeBSD update install, and all the machines are going to install their updates. And then this is a package update. All the machines were just installed recently, so there aren't any updates. But it'll just show true to show that it did the package update command, and then there are no upgrades. That's why there's just lines. But if there were upgrades, it would show you the old version and the new version, which was installed for each package. And then here's me asking all the machines what FreeBSD version they're running, and they all just come back with the latest release and patch version, which is nice. Okay, Ansible quirks. SSH pass, like you've seen. If you don't want to use a key and you're using passwords, you need that SSH pass program. Start at task equals quotes. As you've seen, every time an Ansible command was running, it had a name. You can take that name and put it in start at task when you run a playbook, and it'll start at that spot in the playbook. And that's really nice for building playbooks, because if you're doing it in a step-by-step-by-step manner and you haven't made it idempotent, then you don't want to run all those commands again while you're trying to figure out what you're going to do next. So you just start at task. But then it'll start at task and it'll just automatically go to the end. If you want it to take its time and do one at a time and say, hey, do you want to do this? Yes, no. You can do step. So if you add step, it'll literally ask you yes, no, or continue. So yes is do the one thing and ask me the next one. No is don't do it. And then continue is okay, from now on, just automate. Do the rest of them automatically like you would if I started that task. So that's some Ansible quirks to know about. And then salt quirks. You can't see this very well, but basically minions returned with a non-zero exit code. Sometimes your minions aren't responding. And you're like, what's going on? In this case, it was the captive portal came on. Well, I was doing something, so I took a screenshot. Just wanted to show you that my upstream internet connection died. And then I asked it to do state.highstate, and one of its things is to check if it's on the latest packages, and it wasn't able to do that. And so the minions were like waiting. It's saying the minion didn't return, and it's saying that it's doing something, and there's a job ID associated with what it's doing, and it spits out the ID. So you can go, the cool thing about Salt is it's event-driven, and it's got this whole event bus. So there's this event bus. Just use the event bus. You can see all the events hitting the Salt event bus in the background. You can see the minion keys that were accepted. You can see when a state apply was finished or when it started. Custom events are really cool to dig into, or orchestration events. So this is the command you run. Salt runs state.event pretty equals true. And then you can grep for whatever you're looking for. Or you can just watch it. You can just leave this up and running and just see what's going on. And when you see stuff happening, you can use Salt to create other triggers and react to those things. And you can do anything that you can imagine with an event happened, and now I want to do something based off of that. So now you've kind of built this ecosystem where all your machines run, and you've given yourself the ability to tap into this thing, and it's literally just a log and monitor of everything that's happening. And once you start to dig into it, people have done some pretty creative stuff with it. So that's probably where I'm going to start digging into next, is figuring out cool things that I can do based off events that are happening on my network. And that's it. So if you have any questions, I'd be happy to go over them. I am SSH'd into my real Salt server right now if you want me to run any commands. And thanks to the docs of FreeBSD, Ansible, and Salt. And then also thanks to this guy. I don't know if you heard of him, Benedict. This was where I first took a tutorial in EuroBSDCan. So I recommend doing the tutorials when you come to conferences, because they can set you down a path that can change your whole life. This did change my life. I was sitting at a help desk. I knew my job very, very well, and been there for almost 10 years, and was just geeking out, doing a bunch of hobby stuff. and going to talks, going to conferences, sharing my ideas. And then I just got hit up by a bank saying, we can't find people that know this stuff. There's a good opening, and we would like to see if you're interested. We've seen some of your stuff, and it looks like you know exactly what we need. So I said, sure, and now I've been there for almost 3 years, and it's been an incredible opportunity, and now I'm one of the more invaluable people on the team because you get a lot of people that know a certain thing, that went to school for a certain thing, and they don't see the big picture, or can talk friendly to auditors, or can work together very. So when you actually play with the stuff and you get your head wrapped around it, you become very valuable to people who have these good jobs and they're willing to hire you. So this has really helped me a lot. So I would definitely recommend that. So now I get to live in the forest with my dogs, and I'm much happier. So I'm trying to take it easy and not ride too many fast machines. I disappeared for a minute there because I had an accident on my motorcycle, but I'm back, and I'll try and stay alive for the next foreseeable future and share. Otherwise, you have messes, and people online don't want to help you with your messes because.
Could you give me that model of the 96 gig Dell?
Yes, this is a great machine. So it's called Dell Precision. What is mine called? 7760. Yeah, that was the 7760. Yeah, the 7760 workstation. And they should be on eBay refurbished for an insane deal. Okay.
Does the RAM ECC RAM?
Does it have what?
ECC RAM.
You can get it. Yeah, it's DDR4, so it's thankfully it's the cheaper version. But yeah, I mean, as you'll see on there, you got $780, voila, and throw a couple $100 into hard drives and memory, and you've got an insane machine. Try and find the Xeon ones. They're really good for this kind of work. And try and find one that doesn't have the greatest graphics card of all time, because they'll try and hit you for that. Just get like the T1100 or T1200 or something. Don't try and get like a GTX, because the tax on it is like, what are you going to use the graphics card for anyways on FreeBSD? So, yes. But yeah, that computer's been amazing. And then I use this Evono CPU cooler, or a laptop cooler Evono thing. I can't remember what it's called. Lenovo, I don't remember. But they're like, yeah, it's this thing. They're like $100, but man, this thing is cool. And it won't work on a MacBook. It has to have vents on the bottom of it. But what it does is it creates a little dust-proof seal around it, and it just gets that air moving all the time. And I usually only run it on like 1100, but it goes up to 2800, and it kind of sounds like a jet. So you feel like you got a little server farm, you know? You're like, yeah, I got a server farm. It's great. But I think the best thing that I've noticed about running a lab on a laptop. I used to be a huge desktop guy all the time, but the gamers ruined it for everybody. You can't get a power supply for under $100 anymore, right? So it's like, what the heck are you guys doing? but with the laptop, my power in the forest sometimes will blip just for a split second. So the only thing that turns off is my laptop cooler and the modem. And then the modem comes back online and everything's still working, and I don't have to go maintain anything.
Right, because a high-end laptop or desktop replacement laptop is basically like a server with a built-in UPS.
Yeah. And the battery actually doesn't die all the time. I don't know if you guys have ever tried the APU backup battery thing. It's a nightmare. Suddenly you learn way more about batteries than you ever wanted to know. And
One of the things I did, I got those fanless mini computers they use for restaurants.
Oh yeah.
I got 4 of them, and then I run them all off an ABC 650.
oh, sweet.
And the ABC 650 will keep them running for like 12 hours.
Cool.
You'll repeat it for the
Oh, yes. So he said he's got, what is an APS 650?
APC.
APC 6, I've never heard of it.
The cheap office under your desk UPS.
Oh, it's a UPS, and you're running how many devices on it?
I got 4 of these, plus I got my Starlink and a bunch of other stuff.
Oh, nice.
Same kind of issue.
Yeah.
I live in the forest as well.
Yes, right. So you needed some sort of battery backup.
My power outages are like yours. They're like
Yes.
2 seconds or brownout or whatever.
Yeah.
Occasionally I get a 1 or 2 hour.
So what I use, I've got this thing called a Blue Eddy. It's a big suitcase lithium battery. Yeah, and you can plug solar panels into it. So that thing's nice. I guess I should probably plug my CPU, my laptop cooler into it and keep it running because it has pass-through power. So I could probably just use that to have as my battery backup. But yeah, that's what I use for like backup power if I need it, because that'll run for a little while, and you can plug a fridge into it and keep it going.
For me, it's I'm more worried about the brownouts and stuff.
Yeah.
So like just having a bit of battery that will basically 10 minutes is probably good, but I want to be able to run everything I have, like my desk and my screens and everything for 10 minutes.
Yeah,
But I don't need to run for 4 hours or 8 hours or whatever. I just
right.
because those outages are less frequent.
Yeah, so for Florida, I want everything of mine to be portable because those hurricanes, it's not so, I mean, yeah, the hurricanes are bad, but the people, when the hurricanes come along, their true colors come out. And you suddenly, like 5 people can take all the gas from the whole city somehow because they've got insane amounts of gas capacity and giant trucks, and they don't care. And so whenever that kind of stuff happens, I just go to Tennessee or something and take a lake vacation or something because it's not worth it trying to stay in town for 2 weeks dealing with a bunch of people getting worried and scared, and yeah, they're way too prepared. So you got to be careful with the down southers. But yeah.
Ansible uses YAML, right?
Yep.
Do you edit that by hand or do you use the YAML editor? I've never.
Oh, so I've been doing everything by hand. I use Vim. Oh yeah. Okay. So the question was, does Ansible use YAML, and how are you editing those files? So you're doing it by hand, or is there some sort of editor? I've been doing everything by hand until this last week. The CTO at my work has been using a tool called Windsurf, and it's some Claude-powered IDE thing. And I've talked to ChatGPT before and asked it, like, why would I ever want to use some sort of IDE? I could just ask you questions if I have questions. And it's like, yeah, that's a good point. And then you want to use extra tools. I'm like, exactly. So that's kind of what I've been doing. It's just if I have a question, I can talk to that. But the Windsurf is insane because you can be editing your Ansible playbook and you're trying to like change a variable or something, and it'll be like, oh, I see what you're doing. And you just tab, and it changes it for you, and it finds another place where you need to change. You just tab, 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 and it picks up on what you're doing and starts changing things for you. And then it comes up with ideas and asks you if you want them to do it for you. The CTO at my work actually used it to create AWS organizations with Terraform that have separate accounts, and he can deploy his .NET projects to it, and his APIs and Lambdas all have different sub-Terraforms that all build the things that he needs for the IAM roles and the logs and everything. And he just talked to it. He doesn't know Terraform at all.
I was going to say, you have a CTO who understands computers?
Oh, yeah. because of the way it's so my boss's 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 boss, right? Those guys are all bigwigs, but there's a little section that I work in that was called payments, so we get to do cool stuff. So the CTO of the payments division is a nerd, and that's really fun. But yeah, there's a lot of bigwigs at the bank that just want us to make it a green checkbox show up when there's red checkboxes, and do it quickly. So you've got to know how to. Sometimes those fights take a little bit of goodwill, and you got to know the right people to talk to, because sometimes your coworkers don't want to know the reason. They just want the checkbox to go green, and the reason is because that's not true, and I don't know why your tool is telling it that. So sometimes those are fun, but it's always good to know a bunch of tricks to be able to get around some of those things. You know, just by actually like looking at the program, maybe read the docs. That's my favorite trick, right? Read the manual, because a lot of people like to buy tools from a vendor and implement the tool without, like what the salesman said it would do something. But the goofy thing about vendor, that whole environment is like you'll get a company that sells you a service and tells you that we're going to monitor your logs, and we're going to be your SIEM, and we're going to be your security center, and we're going to alert you and stuff. But then that same company will be contracted to do like an assessment of your environment, and your assessment comes back saying you don't have proper alerting, and you go, did you share that with the guys that sold me your product? Because I'm sure they wouldn't want to hear that. And by the way, we do have monitoring, and and then you got to show them everything. So sometimes it's kind of goofy when the vendor things are just a racket. So it makes you wish everybody would use good tools and understand how they work, but we can't all have nice things. I feel like you're running around all the time being like, we can have clean water, you know? But that's what this kind of stuff is for, is you step away from all the muckety muck, and you get to say, in a perfect world, how would I build something? And you get to explore. And then eventually what ends up happening is someone will approach you from the company being like, hey, we saw you were sharing this stuff and teaching about it. Why don't we do that? And you're like, oh, I've been trying. And then suddenly you get the stamp you needed, and then you can take over. So I've had that happen a few times, and it's so cool. So I think that's the best way to do it. It's not to always push back, but to kind of just forge your own path, and then people will notice, and then they'll kind of meet back up again. So just try not to get discouraged, and because you can get, like that's why I think I fit real well in a red tape environment, because it doesn't really bug me too much. I see a lot of ways around it, and I like to have the freedom to go around stuff, but not get in trouble for thinking like that. A lot of people think you should get in trouble for some reason, but I don't. So, cool. Well, FreeBSD for the win.
All right. Good afternoon, everyone. This session is about porting a Wayland compositor to NetBSD and OpenBSD. My name is Jeff Raska. I am a site reliability engineer and maybe a little bit of a strange person to be doing graphics work. I live almost entirely on the command line, particularly professionally, and generally don't care super much about what the GUI looks like. In fact, the compositor I've built is very keyboard forward and tries to avoid having much in the way of graphics at all. So, but it's one of those things that I got into it because I knew my X system was not going to be continuing to be supported going into the future, and then realized that I actually liked it quite a bit better. So, with that, just want to get started with a little bit of an introduction to Wayland, because I know there's a lot of information out there and a lot of non-information, a lot of debates. It's a project that's got started kind of in the late aughts, so it's closing in on 15, 16 years old. It's part of the freedesktop.org group folks maintain the core of it. And basically, when we had the Xorg server mature in 20 years ago as the modular system that we use today, a few people realized that you could take it apart and reuse a lot of components and rethink the GUI protocol. Everything had been moving towards using higher performance for local applications, and people hadn't been using the remote applications on X Windows as much. And so everything's built around passing buffers of data, and then also we don't have 2D acceleration in modern graphics hardware. It's emulated now. And so you can remove a lot of the legacy drawing features that X Windows has in its API because they're essentially effectively unused. So as I mentioned, it uses the modular Xorg ecosystem. So Mesa-lib, DRM, kernel mode setting, all that stuff still applies. There's a library called XKB Common, which was them taking apart all of the keyboard handling stuff that's common across X Windows environments and building them into a library and then just reusing a lot of the keyboard map code. So there's a lot of things reused there. It's definitely something that is coming out of the Linux world and was born in the Linux world, so there are some Linuxisms. libinput's a big one. But all in all, it's kind of a fun design. There's definitely a big rollicking community. There's definitely a lot of different camps even within it. So you get KDE folks and GNOME folks, and then a whole bunch of independent compositor developers like myself, and trying to figure out how to get things to work. But all in all, it's definitely not quite as mature as we'd like it for going into production, but it's getting there. And again, the modernness of it, there's a lot of fun stuff with how it can go faster and and a few other things. It does have a few differences with security, and this is one that popped up from a couple. I added this slide at the last minute from a couple conversations over the last 2 days. So because there's no network aspect, it's done through Unix domain sockets for the protocol, and that ends up, you get a little bit more efficiency there, and you also get Unix file system permissions. But that does have a slight problem with it, and then the graphical data gets pushed around in DMA buffs, and the current form of that uses file handles to hand them off between processes. So you end up with a system where the Wayland compositor assumes that everything's going to be run by one user, and so that tends to break accessibility tools. And so the accessibility story under Wayland is abjectly terrible. I make no excuses for that, and I'm hoping that we can figure out how to fix it in the coming years. But on the other hand, there's no network attack surface. You do get to leverage a lot more of the kernel security controls, and the protocol because you've got a combined window manager and display server, the input comes into the display server, and then it gets dispersed to the different programs. And so keyloggers can't go in at the high level that they can on X Windows, right? You can't sniff the input stream. You have to actually get down to the kernel level where the events are coming from. So there's a little bit of a better story there. Screensavers and screen locks are wildly non-uniform. I haven't looked into it for a couple years now because I haven't needed it. Mine doesn't support it yet. But that's kind of my next project. But like, that's definitely been a giant mess of how do we do screensavers. And JWZ has been like poking fun at various the maintainer of X screensaver has been poking fun at everyone because he's only been kind of one of the few people who's really been concentrated on having a screensaver system that actually locks the machine and doesn't let people like trivially bypass it with the right key press. So
successfully defends against the threat model of a cat on your keyboard.
Hey, no, I've had offices where like you had to have a secure screen lock, and if that wasn't locked down, the other guys would go hop on your computer and like send stupid emails or otherwise just prank you. There's certainly places where it matters. But it's, yeah. So, and like you'd like to expect that if you lock your screen, it's actually locked, right? So I will be digging more into that in the near future because that's kind of the next on my feature development list. But it's definitely not something that is, it's definitely one of those places where if you look into the history of it, you'll get a feel for like Wayland being a little bit of the Wild West. And then I've already said display server and compositor a little bit. Those are just kind of, they do the same job as the X server and your window manager combined into one process. And we'll get into more about why how that can be a big advantage. Surface and view, kind of the words I will toss around when I mean window. Surface refers a little bit more to, I'm talking about the drawable bit plane or drawable frame buffer in memory. And then view, I'm talking more about the data structure that the window manager thinks about when you're moving a window around on the screen. The seat it's an abstraction that's meant to represent a keyboard and mouse and monitor setup that, and this is one of the kind of the rough edges where you get the seat abstraction and it's set up so that there's a lot of like, where it clearly whoever sat down to do this meant it to be extensible so you could have a setup where you have a machine that has a bunch of terminals and different users and they're all working on the same composite at the same time. But then, as I mentioned, the compositors themselves tend to assume you're running as one user and only one user. And so there's a kind of a disconnect there. And I don't think anyone's really done anything complicated with that. I certainly haven't seen any compositor that works any differently than a typical X setup. And then the other, Wayland itself as a word is probably the most confusing word here because there's ways in which it is a wire protocol for a GUI application talking to a display server. There's ways where there's a library that FreeDesktop maintains that implements that protocol. And then there's the whole ecosystem of toolkits that support it and applications that support it and compositors and what have you. And I can hopefully it'll be clear from context which one I'm referring to. I'll try to be a little bit better about noting when I'm talking about the library or the ecosystem or just the protocol. Let's see. So, will you have to use it? No! X isn't going anywhere. This is BSD. We put it in our operating systems. You've got your X sets, and we have people that maintain it, particularly in OpenBSD and NetBSD. NIA had a post last year for the state of X Windows on NetBSD and went through like there is still active development on that X server implementation and even pushing back 2D accelerated drivers and hooking them up with more things so that like older machines will run faster and better. And And then Xenokera, clearly in OpenBSD, gets a lot of work and has had a lot of thought and engineering put into it. And I don't think that's going to be dropped, and there's definitely specialists there. Said if I was talking to a group of Linux enthusiasts, the answer on the Linux side of the world is only FreeDesktop does any work on Xorg amongst all the distros, and no one has any specialists there. Almost no developers in the distros have any specialty in keeping Xorg up to date. So, and the FreeDesktop folks don't want to work on Xorg anymore, so it's basically sitting. So like there's a little bit more of an impetus in the Linux world. And I kind of expect what's going to happen is that you're going to see more folks like me. Like FreeBSD already has pretty good support for it. OpenBSD has, in the last year, has gotten pretty good support for Wayland out of the ports tree. And it's just, so there's going to be a little bit more of it. It'll be an option, but no one has to really change what they're doing if you don't want to. Play with it if you do or see something you like. The other reason to welcome Wayland devs is that the display server, particularly like in the WL roots section of the Wayland world, all the rendering is done through the fully accelerated driver pipeline. So you have to have the drivers working all the way and working well, which means that as we come in, we're going to come and fix bugs in the graphics drivers, and then that'll make the X Windows desktops faster and better accelerated and more stable. So like, it's not us trying to change things. It's just there will be ways in which we're trying to make things better. I've got, yes?
There is also a little VM pipe that allows you to run like WL roots compositors without accelerated graphics. Basically emulates it in software.
Oh, that's an interesting one. I'll come talk to me afterwards. I would love to find out about that project. But even still, like, it does me like I've got a couple like small changes into the NetBSD kernel that provided a couple of fixes along the way, and that's slowly been getting better. So we're here to help and have fun and be a part of the community. Like, and I don't want to move anyone's cheese. Okay. Moving on a little bit to how exactly does the protocol work. I'm not going to actually show any diagrams of the wire protocol because effectively that's so stable, I never work with it. The base protocol is very, very simple. There's a bit of object orientation to it where everything you try to ask the compositor about has an object ID, and so you provide an object ID and then an ID for the command you're trying to run or the request you're making and any arguments to it. And so it ends up being a very thin or very minimal standard for the wire protocol, and then there's a protocol development framework built on top of that, and anything you'd actually think of as a part of the protocol is built as an extension. And so the extensions are specified in XML, which I'm not a fan of XML. I've never liked it. This was actually kind of like XML doing a thing that it's really good at and actually rather pleasant to work with. Like it's one of those, every technology it's written to do something, and there's actually even kind of the honor stuff has something it's good at. And this was a nice application of XML. So I've come around on that and don't hate it these days. So that has been fun. And as I was saying, like everything specifies extensions. So like the protocols around the talking to the compositor, the display, anything like even the core requests, they're just XML. They're defined as with XML protocol extensions within the Wayland library source code. And then what you end up doing is taking this XML file, running a program called Wayland Scanner on it, and then that generates little code shims, usually in C, to actually generate the wire protocol for you. And so you don't work with it. You just end up, the XML turns into a function API for the protocol, and you call those, and then it manages the wire for you underneath, and you basically never touch it. And I've never really needed to, like I had one problem that I was debugging where I tried to put a little bit of a sniffer application in between the application and the compositor, but I ended up not really needing that and not being super helpful. This is an example of what that XML looks like. It is taken from my compositor. I've got a custom extension for being able to interact with it with a command line tool. And so this is just a snippet, like how you might, the interface line defines the name of the protocol. There's some built-in like comments and things, and we're generally really good about trying to get the XML document to document itself or have its documentation contained within it to make it more readable. So you can learn a lot about how things work under the hood by just reading the XML files. This just sends an about, has a request block for sending an about request that just returns the version string of the compositor. And then it also has a request that tells the compositor to exit. And then, let's see, can we see that? We can see that, great. So I do that. Like that just ran over, did the XK is it doesn't start up a window, but it does start up a talk to the compositor, and that's the version string for what I'm running right now. And then the rest of the demo is, this is running Open BSD 7.7 on a framework laptop, and I'm using it to present the thing. So this is, yeah. What? Yes? Huh? Oh. I can also do, it's a little bit bigger. Yeah. So yeah, so the demonstration is, hey, you can see slides. But and then this particular compositor, yeah, I don't have a logo. It's like, I'm not a graphics or designer, so like my favorite part of the graphics stuff is the really low level digging into Mesa and the kernel levels. So it's a stacking window manager, very keyboard and CLI forward. That right there, the drop-down terminal, that is the UI for dealing with it. The command line, in my opinion, is just better at anything you do with a mouse and pointer for most managing the computer operations. So just do that is the whole philosophy. It's also got that command line tool XK that has a lot of abilities to list the outputs, or get lists of the windows, and it uses an embedded Lua interpreter. I added it originally for configuration and then realized that because you have the window manager, has anyone here used Awesome WM or is familiar with it at all? A little bit, okay. It's an X Windows window manager that uses an embedded Lua interpreter as its configuration system. And it's really neat, well put together, but it doesn't do much once you've got it started up. The Lua runs at the beginning, and then you just kind of everything, there's no more interaction with it, so particularly. But because I'm the window manager and the X server all in one block, I can put callbacks throughout the compositor and then have it be scriptable. So it's a stacking window manager, but you can have light tiling features where if you type in the impulse 2 command at the beginning triggers a Lua script, which started up my which started up the presentation. So you can do that. I've got the Impulse 1 is my like normal, starts up the browser and a couple terminals and then arranges them depending on how many monitors I've got plugged in. And then it uses kind of a tag system, not unlike Awesome Window Manager, so that you can have windows pop up on different desktops and basically using bitwise logic. So bad, it's perpetually alpha. I'm the only user. I haven't done the screensaver yet. If you were watching, I was shutting it down and starting it up when we were having the technical difficulties right before we got started because I don't have output hot plugging working. I don't like drag and drop, so I didn't actually add that at all. And I might at some point if like users ask for it. There's a lot I can do with Lua right now, but it's definitely like there's a whole bunch more that I would like to do. And then don't turn on the compiler warnings because it's the code base. I always feel like it's kind of a mess, but the reason for that is like I've been learning about all of this as I've been going along and have not had huge amounts of time to go back and clean up everything. So maybe in a couple years it'll be great. But at the same time, it's my daily driver desktop. I use it for work day in and day out. And then the other fun thing with the don't turn on all the compiler warnings though, porting it to OpenBSD was awesome. If you've never built and tested C code on OpenBSD, you really should try it, like particularly if you're maintaining a C project. It will beat you over the head with all of the memory management mistakes you've made because it does not put up with any garbage at all. It will just crash you.
It's like having Theo right there.
Yeah, Theo's right there going, which is awesome. You will get it. You will work out a ton of bugs, and like this is more stable and significantly better because I did this port over the last year. And so definitely going to keep OpenBSD in the regular like test bench and use even once I get NetBSD up and running. I find NetBSD is a little bit better of a match for just how I like to use the computer, but OpenBSD is awesome and I love it. Okay. So now, to move on to my grittier favorite parts, when we start talking about how all of this is set up to work. Let's see, I'm trying to remember. Yeah. Okay, so this is kind of the basic diagram of how all of this is set up. You have an application, the compositor will start up. It'll open Mesa to deal with drawing and rendering and talking to the kernel from the DRM side to get the display set up. And then it'll do a little bit of mode setting. And then and also it will talk to your input event source. And then an application, probably via a toolkit, will open up connections both to the Wayland compositor and to Mesa so that it can set up a surface to draw to, and then ship that surface, details of that surface, over to the compositor. And then all of this is done with memory mapping. So you're not copying buffers. You're just passing around handles in a secure fashion and using the same blocks of memory. So when the compositor pulls the bits out and turns it into a frame, that's the only time you might possibly be doing a copy. And you're probably still not doing a copy. Instead, you're just sending it all down to the graphics driver as textures and saying, arrange them like this. And then it does the work of putting it together. And then, of course, everyone was at Margot's talk this morning, right? You all remember her diagrams about GPUs and how the hardware works? That's all sitting down here. And I don't have to talk about it terribly much. She did it for me, which is awesome. And then, so now next couple slides are going to be focusing kind of on the lower left-hand side of the diagram. I'm sorry, I'm bad at left and right. But first, pardon me, ioctl or IOCTL is like purely written vocabulary for me. If anyone has a preferred pronunciation, shout it at me. IOCTL, great. Tempting. Okay, but I see some grousing periodically online about IOCTLs are a mess, and actually, the harder I think about it, I don't think they are, because again, that first bullet point, file system is the UI abstraction of the Unix kernel. That's kind of what we really mean when we say everything is a file. Like you talk to the kernel through the file system for everything. And so when you're not dealing with like files on like a disk, you're talking about resource addresses like Unix domain sockets or device hardware or device files, and thus pieces of hardware. And so, of course, lots of hardware. You send data to it, you read data from it, and it can look like a file, and that works really well. And then some data, again, thinking back to Margot's talk this morning about how GPUs work, do not work at all well with that model, and they just need a dedicated API. But there's a good engineering trade-off with IOCTLs, and that is they keep the syscall interface in the kernel small and contained. And like everything I've seen is that the people complaining about it kind of want a higher level library with just a bunch of function calls, and then that turns into a mess that gets difficult to port, particularly when you have different architectures that have different amounts of room for a variety of system calls. So I kind of think if the people who are grousing about it are holding IOCTLs wrong. It's just the macro name is the function name. Just ignore the IOCTL there. It's syntactic sugar. The macro name is the function name. And then you have a nice function API. And the reason why I wanted to say this is because the DRM API is probably the biggest, most wide-ranging set of IOCTLs in the kernel for any of our kernels, no matter which BSD we're talking about or Linux, because you've got to deal with hardware configuration, video memory management, the drawing commands themselves, and any number of other like permission handling, passing around buffers, and none of it maps to a file operation well. You just need an API. It doesn't really make sense to like write to the device file for a DRM device. And then the API methods end up being very granular, and they end up being on a per card basis, and which is why we have libDRM, and we'll get to that in a moment. But the other thing that's hiding in here is that you've got two device files typically. There's card0 and render D128. And OpenBSD used to have a different format, but most everyone uses this dev, DRI, card, and render these days. It's a privilege separation mechanism where anybody should be able to open the render node if they've got access to the graphics. And that's the one that just allows drawing commands and setting up buffers. And then the card0 device is for the DRM master, which is just one process on the machine. That's going to be the compositor in Wayland. It'll be the X server if you've got an accelerated X setup. And its job is to set up so that like the screen's got the right resolution and the actual real frame buffer that will actually go out to the screen and send the final drawing commands and what have you. And so that's there. This will come up again. But yeah, okay. So to implement all of this with in our kernels, like fortunately AMD and now a little bit NVIDIA, they only care about Linux, but they did realize a couple decades ago that when they released the code and upstreamed it into Linux, It would be better if it was BSD licensed rather than GPL licensed, so it could be used across other operating systems. And so you'll find that I think OpenBSD 7.7 uses the code from Linux 6.12. NetBSD 9.10 and current, I think, are from a 5.6 kernel, and Dragonfly is a 4.4. And that all means like OpenBSD runs great on this laptop. It's relatively modern AMD hardware, and it should work on the AMD board that Framework just released, so I might actually be able to get the next upgrade and have things work. But it does mean that like NetBSD and Dragonfly work better with cards that are more around 10 years old. And then FreeBSD tends to be pretty up to date and tracks pretty well to as much as is available out there. But the other thing, though, is that one thing that there's a lot of things that Linux does where they've got procfs and sysfs, and we'll do things through that mechanism that we don't have and we don't need. So it ends up that we have a bunch of little modifications. There's a shim of code that goes wraps around the Linux portion of the drivers to adapt it between to like how does a device driver in a BSD kernel work, and then there are, which means that you get this funny thing where if you're going through the code, there's a lot of traps in the DRM code where you'll have a structure that's the exact same as the one in Linux, but we don't use all of all the members of it. Like there are some things that are just not going to be set; they'll be null and can't be tracked through. And you just kind of got to be aware that that pitfall is there if you're looking at that code. And then, of course, we've all evolved a little bit differently over the years, and so every kernel does things a little differently. I'll have an example of that in just a moment. And then we often, again, to make up for the lack of sysfs and procfs, particularly OpenBSD, NetBSD, use extra ioctls. So we have even more added to the DRM API. And then libdrm itself, again, that grousing that I see about ioctls, I think libdrm is what they actually want, which is just a nice little library that sits on top of it. Part of the reason it's there is because, again, that the API at the kernel level is per card and granular, and the libdrm API is a little bit more of like, hey, give me a file descriptor to the main graphics card, and then you don't care what the device file it is. It'll actually go through and find, libdrm goes through and finds the one that's actually attached to the kernel, or all of them are attached to the kernel, and reports back. And then it'll also do all the things needed to open a file handle. And there's usually a little bit of extra setup work that goes into that. Which is why like a single libdrm function will make a bunch of ioctl calls into the driver. And then on top of just having that libdrm API, the AMD GPU has a whole bunch of extra ioctls. Novo has a different set. Intel i9-15 has a completely different set of its own. And so there is libdrm Radeon, libdrm, I think it's Novo, libdrm Intel, and a few others to handle all of that complexity. And then so that largely hides the different drivers from Mesa. And so, or allows Mesa to have a lot of code that's more generic than it otherwise would be. But again, we all do it a little differently. So everything, like libdrm itself, it's a small library, but it is kind of 4 or 5 libraries interleaved with ifdefs, one for each operating system, living in the same file. So again, because Linux heavily uses procfs and sysfs, and then we run different, and we do a lot of that through ioctls that are extra. So one example of that is DRM parse PCI bus info. So there is, you get every card, basically PCI is the bus that we use for GPUs in commodity hardware. And so you've got the PCI bus address, which is a domain number, a bus number, the device number, and then the function. And just a series of 4 addresses. If you've worked with PCI drivers, those will be familiar. If you haven't, just realize it's 4 small integers that tells you where the card got plugged into in the machine. But that information ends up in a couple places. But Mesa wants it when it's initializing a card. And so when you go, hey, open DRM file descriptor, this will get called somewhere in that process. Linux figures this out by tracking through and making a bunch of file system calls into like the ZFS file system. FreeBSD has a dedicated sysctl call that it makes, and then OpenBSD Dragonfly added this DRM ioctl get PCI info to the DRM API, and that just literally you send it a struct that has domain, bus, device, function, and it spits that back out for the card. And then the NetBSD extends get unique, and the unique is a string that's set during the device initialization on the DRM master file descriptor, and it's built from PCI : and then the domain : bus : device : function, and so then you can parse that string out and get the numbers back. But there's a catch there. Remember get unique. That will come back and bite us a little bit. So should things be harmonized? I don't know. Works fine. All right. Just wanted to pop this up again since we're going to be, I think we're moving to the top section for a little bit more about application, talking to both the compositor and Mesa. I do a lot of work with EGL, and so when the compositor starts up, it starts up EGL with platform DRM, which basically is kind of the same way that an accelerated X server will start up. It starts itself up, makes itself DRM master, and then sets up EGL to use with this platform DRM backend. And again, because it's taking on the role of the X server, so that is well supported across the vendor Mesas in all of the BSDs. Where the catch happens is when you get into applications. You can use Vulkan's kind of becoming more popular, and I think has less going on here. But I have yet to actually dig into Vulkan in any significant way, so don't trust what I say on Vulkan. But the Mesa will actually, in the EGL library, when you're using it to draw a Wayland for a Wayland, it will do the buffer negotiation for you. So when you start up the application, it negotiates with the compositor to set up the screen, and then to set up the view and surface. But to set up the buffer, it actually dips through Mesa. So there's kind of really 2 lines there, where one of them is the compositor talking to Mesa to actually draw stuff to the screen, and the other one is the application. Modern weird bits of hardware, but I typically use a keyboard and a normal mouse, so it's plenty for me. It does have some interesting quirks. It supports a lot of different keyboard encodings, but the 2 that I usually end up running are the PCAT and the USB keyboard map. And this laptop, the keyboard on the laptop detects under OpenBSD, and at least certainly the other laptop also has this problem. The keyboard detects as a PCAT keyboard, and so I'll get those events through the MUX. But then if I plug a USB keyboard in, those events will also go through the MUX, but they'll be in their respective map. And then when you ask the MUX what the map is, you'll get one answer, and so one keyboard will spit garbage, and the other keyboard will not. Now, so I've been still kind of struggling with trying to how to work around this because I did want to like check to see if there's a USB keyboard plugged in, but it turns out that like the volume keys on this laptop go in through a separate keyboard device, and that ends up looking like a USB keyboard to OpenBSD, so it looks like I always have a USB keyboard plugged in on this laptop. But anyway, the other fun thing is that OpenBSD does something spooky that I haven't figured out yet, where it will have both keyboards will work fine in the console, and both keyboards will work fine in X Windows, but then I'll have the broken behavior in my compositor, and I haven't figured out what magic is going on under the hood there. The fun thing under NetBSD is that NetBSD does no translation whatsoever. So if you do this on a NetBSD machine, you will find out that your console will have one keyboard will work and one keyboard will print garbage. So like, it's at least consistently broken on NetBSD. There's some possible fixes to this. I'm probably going to bug people on both operating systems at some point in the next year. But again, and a lot of thanks to Nia for the SWC port, because that provided a nice example for how to work with WSCons. Again, very simple, lovely thing to work with. So with my compositor, I have been tracking WL roots I started this code base 6 or 7 years ago, and have seen every time WL roots does a major rev, they have significant API breaking changes, and the last 2 rounds of that were things that I did not want to implement. And so I ended up vendoring the older versions and decided, because there's also a bunch of stuff that I just wanted to maintain personally and dig into and modify within WL roots. Particularly, I've got some plans around how copy and paste is managed. So that ended up being the right decision for me, and it also meant that like doing the NetBSD port meant I could just do it, and I'm not trying to like convince a bunch of Linux guys to support this like strange NetBSD backend. So the 2 big sticking points on WL roots for me was the input backend. So it needs a WSCons backend. There's and then the seat backend, like the seat, they forked out the seat stuff into a separate library called libseat, and particularly on Linux and FreeBSD, that library does a bunch of work because it turns out it's fairly complicated to get from a virtual terminal up to an actual working GUI on those systems, where you kind of just open the devices and start drawing on NetBSD, and it's fine. So I've got examples of those. The Wayland libraries in package source actually directly patch it to use KQ, and so like it's more of a native native BSD style for even libwayland, and so that could be something that could be done if someone ever wanted to get WL roots running on NetBSD. I would definitely happily like advise. But I don't need to do it because I vendored that code and it works on my system. So I do have a lot of thank yous. I've mentioned Nia a couple times already, and Taylor at least once. Both of them have been extremely helpful. Taylor very directly. I don't know if he's in the room at all. There! You are wonderful to work with, and I have enjoyed every interaction I've had with you. You're super helpful. Thank you so much. And like, I would not have gotten anywhere near as far without Taylor's help. Nia has done a bunch of great blog posts on Wayland and NetBSD and X on NetBSD, and then did that SWC port, which like I largely cribbed the WSCons code from. Of course, OpenBSD dev team, and then OpenBSD ports maintainers. They've got, again, a working Wayland package tree. You can go run this right now on OpenBSD if you want to use Sway, which is a rather nice piece of code. I'm just not a big tiling window manager guy, and I had some other ideas that I wanted to implement. I've used Sway, and the WL roots teams are also on my thank yous because I use them a lot as like trying to figure out how does this thing work. I go read their code, and it ends up being a good way to look at it. Big thank you to the NetBSD dev team, the package source maintainers, freedesktop.org, and of course, all of the organizers and volunteers putting on BSDCan. And letting me come up here and jabber at you for most of an hour. So there is a lot of future work that needs to be done. If you hadn't gotten the gist of it, there's a lot of like, this is just working in a few cases and kind of broken in a lot of other cases, and maybe it'll get there soon. The NetBSD AMD GPU drivers just need a lot more love. And then I need to figure, and that first bullet point's actually probably a bug on my plate for figuring out how to use the BSD Mesa without needing the Wayland support into EGL library. Still fighting with the mixed keyboard stuff. That's probably going to be I need to bring that up on the mailing list and discuss that. I'd like to see package source split out Mesa. I've been using package source on Linux and have kind of like most of a more advanced Mesa package. It would be nice to get that. I'm hoping to get time to like set Mesa up so that it looks like Python, where you can pick which version you want and have the old Amber version be the default so that it doesn't mess with anyone's current setups. But if you want the newer, shinier thing, it's there and ready to go. Again, my compositor is great for my daily work, but there's a lot of stuff that I would love to see it be able to do. And then there's a couple of like shutdown cleanup bugs. There's a good chance that when I turn this compositor off, I am not going to get keyboard input into the command line on OpenBSD. It just does that one time in 10. I have no idea why yet. And then the DRM shutdown code just is not there at all. Like you get to the DRM last close, and then the function that would normally go poke the WS console doesn't have any code in it. So if you start up the fully accelerated graphics queue and then shut it down, you wind up with a blank screen. But that's just a to-do that, I mean, again, it's a small team. We don't have a lot of people doing things. Not everything's getting done. It'll get there eventually. And then I should file bugs instead of surprising devs in a conference talk. So like, if you're hearing about this the first time, that's my fault, not yours. So there's a lot of stuff to be done. But it's all tractable and doable. And I'm super excited to be able to use this more. And it's very close. Like if I can just figure out how to be able to do the video calls for work, I'm going to switch over to OpenBSD for my like work setup. But anyway, thank you all for coming to my talk. Do you have any questions?
How do you pronounce that?
I usually say Zweig. It is like, again, because of the drop-down terminal was definitely inspired by Quake 1. And like for a long time, I'd implemented a dirty hack which took Xterm and put it into a bigger window, and that the window hijacked the F1 key in my X setup and with a key grab. And that mostly worked and got me kind of this setup under X Windows. And then I realized with Wayland I could make it a better, well-engineered thing. And so the name was the name of my original dirty hack that I never published, and I decided to keep it out of like nostalgia.
Is it based on the layer shell protocol?
No, layer shell is about a thing I'm like planning to add in the next month or two, but this is literally, there is a special block in the frame drawing, or the output frame, that checks to see if it should draw this, and if so, it does it last. So it will be more on top than even the layer shells on top. Just because I want it is the UI element, it's always there.
Is this code in a public repository?
Yes, it is.
Worth trying to do anything with it if you're not you?
Maybe. Yeah, it's up on my source hut. If anyone's curious, I'm happy to. I should probably have put the link in here. I think it might be in the program. I don't remember if that got edited out or not. And I'm getting a time. So thank you all.
Hi. Testing, testing. Testing. Okay. Okay, so it's time to get started. So hello everyone, I am Hiroki, and my presentation is titled as Automated Distributed Testing using TTCN3. I used automated distributed in the title, but contents focus on what is TTCN3 and how to use on the FreeBSD. And the URL on the top of the slide is shown all the time during the presentation. So if you are interested in reading the slide, please download the PDF file. So the outline of my talk is listed on this slide. First, I am a FreeBSD committer for a long time, over 25 years right now, and working on the various field. And I'm a co-team member and a Docker team member as of today. And I will talk about the testing framework, and including the current FreeBSD project, the testing framework briefly, because what is the advantage or disadvantage of the TTCN testing framework? To understand that we need to compare, or we need to understand the current framework. And then I will talk about the TTCN3 as in the presentation title. Okay, the first topic is testing of FreeBSD, not the testing on FreeBSD. FreeBSD has its own automated testing suite under user test, as you know. And results of the user tests are available not only for developers, but also for the users, because testing is also useful for the end users. And the source files of the user tests are under the user source tests, and the package-specific directories like user source bin ls tests. And all of the test cases, the scenario is organized using the QR framework, and details are explained in the manual page tests, section 7. And basically, you can try the test framework, the test suite, by installing QR utility using a package command, and then QR utility, run the QR utility with the options such as the tests and specifying the QR file under user test. This command will do every single testing scenarios available under user test. So it takes a long time, and the results will be stored under your home directory by default, .qr directory, and the database is created under that directory. And the contents is not human readable, so if you want to get the human readable output, you need to evoke the QR report subcommand like this. So the reason why the user tests available also for the users is the user can use the testing scenario to double check the behavior of the Flash installation of FreeBSD. But as a project, we are using this testing framework, of course, for development aid to detect unexpected bugs with regressions. So providing the officially maintained automated test suites is essential for quality assurance in the project. So this is why the testing suite is inside the base system. So let's move on to the topic of the testing framework we are using. QR is the testing framework name. It is developed by NetBSD developer Julio. Probably Julio is around here because he is on the speaker list this year's BSDCan. But it is a GSOC project, one of the GSOC project results. And after that, QR is evolved much. And FreeBSD started to use the QR and library part, the ATF, extensively to build up the testing framework, testing scenarios. But more generally speaking, the testing framework like QR, what we are using consists of test cases and test case description capability, usually written in some kind of programming language, and the test case runtime framework. It may be just a command, or it may be some system, and the reporting capability. So these three parts are generally considered as a testing framework. And the QR is a runtime part and reporting part. So QR directly is not directly connected to the concept of test case description. And for that, we are using the C program or C++ or shell script or that kind of program language we can use. And writing the test scenario in a programming language, then the scenarios are invoked in the operating system. The QR will handle the evocation part and collecting the report from the evocation of the binaries. And so QR is neutral in terms of the description part, and basically supporting the TAP, the test anything protocol outputs, and ATF library. So this is a simple example of test anything protocol. It's when the test anything protocol is used. This is a simplified version of the testing cases for the test command, basic Unix command. And the output of the test scenario is something like this. And this output format is specified as test anything protocol. And the header is number of test scenario, in this case, the 1 to 8. And then an OK or not OK is listed. Simple lines. So the running the test, if everything is working as designed, all of the scenarios result OK. And the second column is just a testing scenario number. So running a test, and QR will pick up this output as a result, and all of this scenario passed, the result will be just marked as success. And QR has a configuration file called the QR file here. And in the example in the previous slide, the QR test and this file is specified as an argument. And inside the QR file, what kind of test scenario is, must be run by QR, and what protocol is used to report back to QR system. And the top test program means the legacy test is the file name of the program. It is just a shell script. And the legacy test is invoked. Then the output is fed to QR, and the protocol is interpreted. The output is interpreted as syntax of the TAP, test anything protocol. But in the case of the library, it is difficult to run the library directly on the Chrome line. So we need some commands or some binary that uses library to exports the internal state or results to where the QR can look into it. So for LibM, tests are under user source lib msum tests, and not the number test.c, you can see, and it has a lot of lines inside the file, but the test number, test NN function you can find, and you can see some keywords, some macros from prefixed by the ATF something. So these macros are used for testing, so connecting the binary to a QR system. So in this case, a test anything protocol is not used because so formatting the OK or not OK output using the main function is it is not impossible technically, but it is a common part for every functions in this library if you want to test every function. So to minimize the burden, so ATF library is used. So ATF library can minimize that label as part of creating the test scenario. So ATF-TC head or ATF-TC without head, this line define the test case NAN, not a number. And the target of the test is not the number F. So F means a float. That's return value, return type. And this test NAN accepts the string expression of number. So this string is tested by the actual function, and result will be reported back to QR using the ATF require. And ATF require means the expression in the argument is evaluated as whether true or false, and it must be true if the test succeeds. So is NAN means the argument AF0 is not a number or not, and if not a number, the return value is true, and it means the test passes. And the actual argument is listed on the ATF-TC body. This is a macro, but expanded to functions used in the test cases. And the test NAN 0x1234. This is not a number or not. And so how about the empty string? So these argument and what is expected results are totally depending on the what do you want to test. But in a C program, you can use the ATF library and the macros to define the test cases in our framework. And the QR file is simpler than the C program. Not at the top, the ATF test program is defined here. The QR will pick up the NAN test binary and receive the results in the way of the ATF library. So what is the problem of our testing framework? In short, there is no problem. So I do not intend to blame the current testing framework structure or trying to replace them with other one. But then yes, testing framework is working well and probably simple to understand for developers, even for users. But there are challenges in general for the testing framework. It is there is no exception even for our testing framework. So I summarized the challenges into the three points. The first one is the maintenance, and the second point is the quality assurance, and the third one is complex test cases. Oh. So first one is maintenanceability of the test scenarios, test cases. So how many test cases we have can be roughly estimated by using the how many QR files inside the user tests. And we have 1,000 QR file here. So not every QR file is connected to test cases, but at least we have one. So we have hundreds or more test scenarios. And those scenarios are written in programming language, even if a single case is usually very small and easy to understand. But test scenarios usually increase monotonically over time. We do not delete or remove the test scenarios if as long as the standard or specification remains. So the test scenario is, if the test scenario is increasing, the maintenance of the scenario becomes a problem at some point. And 1,000 is not so big number compared to the commercial product and enterprise users. But as a volunteer project, the number of scenarios and the quality of the test cases can be a problem. And written in shell script, or written in C program, written in C language, I do not have a serious concern. But written in Python, for example, the Python has a history that the Python syntax is changed at some point of the so version 2 to version 3, or, for example. And in a case, the test case can fail because of the language runtime side, not test success or test failure. So that kind of events occurred frequently. Maintenance of the test framework in a test scenario will be hard. So fixing is not hard, but this is a matter of time, a matter of additional cost in terms of time and manpower. So we tend to be conservative and less dependency in the test framework. It is a general direction we have to take. And the second one is the quality assurance. So testing cases, the testing scenarios are written in the regular programming language, so we can have a bug inside the test program. But we cannot have a test for the test cases because it is, so everlasting relationship. So there is no perfect solution, honestly speaking, but we need to be careful. And to be careful, we need to keep the size of a test. Should be test small enough so that we can understand. So we want to have more tests to make the FreeBSD reliable, but we need, at the same time, we need to keep the test suite as small as possible. At the same time, of course, we do not lose the goal of the test. So to mitigate this problem, if someone else develops the test scenario, test framework, we can reuse, we should use it. Because maintaining the test cases, test framework, and the project is not so fun or important. So what we want to do is developing the main part of the operating system. So we do not want to spend more time for testing only, if possible. So considering the leveraging the results from someone else, it'll be good, generally good. And of course, we need to have reliable implementation if we use them as test cases or test framework. But this is a point we have to consider for long-term maintenance. And the third one is the capability of testing. And the complex test cases across the multiple systems are sometimes, so we want this kind of test sometimes. But implementing the test across the multiple systems is pretty difficult. It is not impossible technically, and you can write several shell scripts to invoke the SSH and connect to other machines and feeding the command line into the remote machine and try to establish a connection and then do some testing. It is impossible, but it tends to be not so reliable system and difficult to maintain. And so a good example of this kind of testing is performance testing, especially a networking subsystem. So this slide says the packet forwarding performance testing is one of the example. And of course, we can use the jail or Beehive as a foundation of the packet forwarding testing, but it can test only at functionality part. You cannot do for the performance measuring because virtual environment is just functions on the same machine. So you want to measure the real bare metal performance. You need, say, the 3 nodes and connected by physical wires. So for such setups, QR can handle actually because the QR is just a one-time and the logging reporting part. So as long as you can develop the test scenario binary that supports the multiple system in some way, QR can receive the report. The difficult part is developing the testing binary to realize the performing the test scenario across the multiple system. So there is no consistent framework at this moment, at least on the FreeBSD test suite. Okay, so the problem is that these 3 points is not so generic, and it is biased a bit. But let's see that what is being done for these problems in industry. And this is a point in my presentation today. So, and it leads to the introduction of the TTCN3. So TTCN3 is a testing framework, mainly used in the industry, so telecommunication industry more specifically. And the TTCN3 is a specification and a standard, and standardized by the ETSI, Europe Telecommunication Standards Institute, and endorsed by ITU, International Telecommunication Union, and extensively used in so the cell phone protocol and the communication between the station and the satellite, or that kind of communication. And the first implementation of TTCN was almost over the 40 years. And at the time, the name was tree and the tabular combined notation. It is also the TTCN, but currently that is TTCN stands for the testing and the test control notation. And the name, the tree and the tabular combined notation, is originated from the attitude of standards body, TSI. The goal is the testing based on the diagram. So usually protocol design is done using some messy passing diagram or a specification compiled into the table. So their goal at the time was testing is done by the protocol designer, not software developer. So the protocol designer has a specification in the diagram of the table. So put the information into the computer software called the TTCN. You can get the testing automation by leveraging the software technology. That is the goal. So that is because that is the reason why it was called the tree and the tabular combined notation. But no one understands this as a testing framework, so at some point the name was changed to the testing and test control notation. And the version is updated, but this version was released 25 years ago. So the specification is pretty mature and already used in designing the protocol, new protocol, and testing the actual products for a very long time. And the specification released by ITU tends to be lengthy and very the result of the perfectionism compared to the IETF standard. So mentioned in the third bullet, this specification is actually a part of the OSI reference model. You already know the 7-layered model of the communication, but these are considered over-engineered concept from people in the Unix world or the internet. But the TTCN3 or TTCN original version was developed to test the kind of complex layered system. So the specification is difficult to understand. I cannot explain everything in 20 minutes or so. So I summarized the things into what we should know before trying to use the TTCN3 software. I will explain in the later slide. First thing you have to understand is that TTCN3 has a lot of things, including the language specification, the runtime specification, interfaces, but the purpose is black box testing. In the telecommunication industry, the implementation details does not matter. So the specification is always specified the communication protocol. So the TTCN test module is defined. It has a knowledge about the protocol, the communication, and the message exchange. And the system under test, this is a target, is we do not know if this works as designed or not. So the test module is developed first, and this will send a message to system under test first. And the system under test responds based on the specification and the design, and generate the output to pass to test module. And the test module will examine the contents of the output and judge this message passing is correct or not based on the specification. This is a sandbox testing, and all of the communication protocols are tested in this way. So TTCN3 specification is optimized to realize this kind of testing. But you can leverage this specification for other testing because the test architecture is generic enough. And this is on the specification. And there are a lot of elements around the system under test. And the SVT adapter, the platform adapter, and the TTCN executable binary, and the logging, and the codec. And it's pretty difficult to understand. So let's see this architecture by using an example. One of the reasons why I tried to learn the TTCN3 in the first place was I want to modernize the IPv6 protocol conformance testing. IPv6 ready logo was popular 20 years ago. So, and the testing suite was available from the consortium who are interested in the IPv6 standard. But the currently testing suite are not, so the organization is not active anymore. And testing suite are available in a permissive license, but the implementation is terrible. It depends on the hardware access, and so it's not portable. And for multiple system, testing for involving the multiple systems, so it uses the serial console access. And inside the test suite, the device node is hard-coded. And so you have to reproduce the test environment carefully by reading the inside of the test scenario and the test cases. So very old. So it depends on the platform, and the FreeBSD can be FreeBSD was usable, but at some point, so Linux is used, and the device node name is totally different. And so I used the test suite by patching to support the FreeBSD for some time. But yeah, internal structure is too platform specific and difficult to maintain. So I gave so I've heard that TTCN3 is currently used in the cell phone industry, even for the IPv6 protocol conformance testing. So that was the reason why I tried this system. So in the case of IPv6 protocol conformance, this is a more concrete goal. That diagram can be rewritten in this way. And a system under test is, of course, a FreeBSD system. And SUT adapter, the platform adapter located just above the system under test, can be interpreted as an Ethernet driver and or service such as timer. And the test program corresponding to binary generated by the QR framework we are using is metal boxes on the bottom side of the diagram. So test program you wrote here. This is binary. You can think this is a single binary. But this single binary cannot communicate the system under test directly because this program does not know how to communicate to operating system. So if your program wants to send a packet, the Ethernet frame is generated by this inside this binary. But sending the frame to operating system is down in another software components. In the actual implementation, this part, between your program and the operating system, this driver on OS, this part is implemented as just a library. So your program must call a specific function to send a message to FreeBSD. That is depicted by using arrows here. So test program can send something to operating system via this layer, and your program can receive the information from the operating system via this layer. And another layer is located on the right-hand side, and it says the OS service like timer. And your program may want to use the timer facility to arrange the packet sending in a time axis, for example, to check if the timeout is working as designed or not according to the protocol specification. But your binary is independent from the operating system, so you cannot use the OS service directly. So you need the OS-dependent library and the OS service, such as timer, this software component is that. In the TTCN3 specification, carefully separate OS-dependent part and communication between your program, test program, and the system under test in this way. And the interface between your program and other components are specified as a TTCN3 specification. So this part, this line, is named the runtime interface. And this line is called the control interface. So in practice, you will have a program here, and this program uses the two application interface to communicate to the system under test and operating system that the test binary runs, and the report must be sent back to the controller of the test framework. And that communication will be done using the logging function, and then all of the results will be sent to the runtime toolchain. And if you want to testing across the lot of machines at the same time or in order, you want to change the parameters, say the IP address or some testing number. In that case, you can use the parameter file and passed from the runtime to the chain. So the runtime to the chain is responsible for invoking your program. That might be on the same machine, or that might be a different machine. But this tool will be responsible for that. And parameter file, the configuration file, will be distributed via the control interface. So you do not need to implement a part that reads the configuration file. You do not need to consider about what format or what parameters are passed in your program. All of the facilities are defined as specification. And in practice, as I mentioned already, these components are not physically separated. It is just a collection of functions in the C program level. So the implementation, there are a lot of implementation of the TTCN3, but fortunately, we have the open source implementation. Implementing the ITU endorsed or ITU designed specification is usually pretty difficult because specification is pretty large. But fortunately, TTCN3 implementation is maintained by the commercial company, the Ericsson, and it is maintained in a Eclipse foundation. So, and a lot of telecommunication industry, the commercial companies are using this, and they have own implementation. And I committed the ports yesterday as a develop Eclipse Titan. So if you're interested in, you can install this and try on your box, because it is not so big program. And I will show the example later. And you can run the simple test case on your box. And this program is pretty portable. And when I look into the source code, it says the FreeBSD is natively supported in the first place. And keyword like Linux, Wallis, and Cygwin you can find. And probably a developer 25 years ago, the Solaris was used in the commercial product, and the FreeBSD was one of the cheaper alternative inside the company, I guess. But I don't know the precise. I don't know the reason precisely, but probably the FreeBSD was actively used at the time. But so supporting this program, the porting of this program is pretty easy if the system is POSIX compliant. So, so the reason why I introduced TTCN3 is it looks interesting, it looks useful, even for the operating system testing. So let's see the pros and cons, disadvantage and disadvantage when we use this as a framework for OS testing. First advantage is that this framework is very flexible, and we can use this to build a very small testing case, and using the same framework to build the large scale involving the multiple systems testing in a consistent way. And the technology used inside the Eclipse Titan is very old-fashioned, honestly speaking, in the 90s technology. So I will explain the details of the inside structure in the later slide. But the advantage is a consistent framework and highly modularized. So you can write the very small test in a big module, or you can split everything into the several parts. And the reliability is proven by the commercial usage of this framework. And the disadvantage is the TTCN3 is another domain-specific language. And it's similar to C or C++, but you have to learn how to write the TTCN3 language. And the operating system interface, I will explain the details, but the interface between your testing program and the system auto test part must be implemented separately, because operating system specific part is not a part of a TTCN specification. So interface is defined, but if we want to use the, if we want to send a packet from the FreeBSD interface, the TTCN3 does not know anything about the structure of the operating system side. So you have to write the interface using the API of the TTCN3. So we have to teach our OS to TTCN3. So to implement that, the OS interface requires the C++ implementation. So that is two parts are probably a disadvantage because they required additional engineering effort. But the big advantage is already available industry standard conformance testing can be reused. And this is test suite listed on the ETSI website. So you can see the cell phone protocol that is not so attractive for us, but the IP multicast or IPv6 or so TCP/IP protocol suite are also supported. So you can reuse the library. You can reuse them as a library and try to test our network stack or just part of the protocol. And interestingly, someone at Intel tried to implement the TCP testing suite using a TTCN. You can find this on GitHub. And this project is not maintained anymore, but you can see the TTCN implementation of the TCP state machine. And this is independent implementation of the TCP. And if we want to use this to test our network stack, the task we have to do is writing the connecting part from the TTCN3 and FreeBSD's network interface. And there are several ways, and there are some already existing interface implementation, like a socket interface. So we can reuse this on FreeBSD and or other OSs easily. So let's see how it works and how long do I have? 35 already running out. So so give me 5 minutes or 10 minutes to explain how it works. So let's see the Hello World program in the TTCN3. So this is the program listing, the complete program listing of the Hello World program. And this has two test cases. So basically, Hello World part is just the left-hand side. But this is one big file is split into the left column and the right column. And you can get this file using this file name plus this URL. So you can concatenate the FreeBSD slash the first half of this URL, and you can use this file name. You can get the TTCN file. And OK, so let me explain what this means. First, the module is a basic unit for the TTCN3. So this corresponds to file. So this file is named the Hello World. This is the module. Everything is inside the module. And you can define the ports and the components and the test case. But it's difficult to understand using this, but so I can explain this in the diagram. Hello World test cases designed using this diagram. So this is familiar, much familiar for the protocol designer. The purpose is just send the Hello World string to system out test. The system out test will emit the Hello World string on the screen. To do that, the test component must be defined first. This is the central part of the test. And the test part, this component must be capable to send a message to the system out test. So the communication channel must be established. this is called port, and named myPCO this in its implementation. So MTC type is just a name, component name. You do not need to care about the meaning of the MTC type. This is just a label. And the components is defined, and the port is defined. The port must be connected, and the system under test will receive the message from the component over this line. This is the basic structure. And in the program listing, the port is defined here. PCO type port is defined here. And inside the definition, what kind of data will be transferred. First string means a 7-bit, the alphabet string. And the second type component statement defines the component. This is the central part of the communication. And the component has a port, and the PCO type is defined here. So port PCO type is defined inside the component, and myPCO is the name of the port. A single port is defined here. And you have a port and you have components right now. So you can define the test case. The test case is the execution unit that what kind of test you want to do. And the test case is always associated with the component. So test case, the hello world, this is just a label, and it runs on MCT type. This declaration means that this test case depends on this component. And inside the test case block, first thing is mapping or connecting the two ports. Because the declaration of the port does not mean anything about the connection. So this connection, the component and system under test. Testing. So like the POSIX